We should be live over on youtube.com. Let me just grab that link. Here we are. Okay. So if you want to access the stream over at youtube.com, you can do so over at the link I'm sharing in the chat. Otherwise, you can stay in Zoom, and that is perfectly fine as well. All right, so we're going to start the lesson, and today what we're doing is we're doing HackerFrogs After School Linux Basics with PicoCTF, and this is part 4. So what did we learn in the previous workshop? Hey there, HackerFrogs. This is the 4th Intro to Linux OS Operations workshop, and in the previous workshop, we learned about the following Linux commands. So we learned about the netcat command. Netcat is a versatile computer networking program, and one common use of netcat, with the PicoCTF challenges anyways, is to connect to non-standard services on remote servers. Remember that a remote server is basically any computer that's not yours that is also on the same network. So if there's a computer on the internet and we're contacting it, that's called a remote server. We also learned about command piping. Command piping is the process of passing the output of one command into the input of a second command via use of the Linux pipe character. So we used a lot of piping when we learned about the grep command inside of Linux. We also talked a bit about the base64 command. Base64 encodes and decodes data according to the base64 format. It's often used to convert data for transmission across computer networks. And we learned about the echo command. It's used to create output to whatever is supplied to it. It can be used to supply input to another command through command piping. And we learned about output redirection, which is a useful feature in Linux that can be used to direct the outputs of commands and write that output into a file. So what we're going to do is we're going to access a Linux console for our educational needs at the following URL. So that would be the JS Linux right over here. So if you are not on that page, that you can always access it from the link that I've provided in the chat. So the first thing we're going to learn about is the ampersand operator. So the ampersand operator is used to execute command as a background process. So anytime you've got a program that's running in the background, we call that a background process. And if we run it with this character right over here, that means that the command line interface terminal will be free to execute other commands while the process is running. So let's see an example of this. So over at JS Linux, we're going to run the following command. It's going to be we're going to try looking for something in the file system, and we're going to look for it everywhere, which is this slash right here. That means look everywhere in the file system. We're going to give it a dash name, so it's going to look for a certain name. And we're going to look for a file called the HackerFrogs. And since this doesn't exist, this find command is going to run for a long time. But if we give it this and symbol over here, so the and symbol is the and or ampersand symbol is the shifted version of the number 7. So if we give this command over here, then we'll see that it's going to run, but with the process ID of 184. So we can actually look at the processes that are running on the system with the ps command, processes. And it's going to tell us which commands are currently running on the system over here. We've got this sh command, which is our current shell. We've got the find command, which we ran in the background. and we have the PS command, which we just ran. And each one of these processes is going to have a process ID number associated with it. So if we wanted to close out or stop any of these, we would have to use the kill command. And it sounds kind of cool, kill command, but it just means that we're going to stop a program. And when we use the kill command over here, we're just going to need to provide the process ID number for whatever we want to get rid of. So if we want to get rid of the find command that is running, we do kill and then space and then the number. So after we do that, and then we use the PS command again, we're going to see that that this process was terminated. So to all the new students coming in right now, what we're doing is we're working with our JS Linux, which is over at the following link. So please go over to that link, and then you can follow along with us on your own Linux console. Okay? Okay, so next we're going to learn about the double AND operator, the double ampersand operator rather. So this operator is used to execute the two commands to the left and right of the operator, one after another, but will only execute the second command if the first command executed successfully. So basically we can think of this as a way we can run two commands at the same time. So back at JS Linux, say we wanted to run the whoami command, and we also want to run the pwd command. So the first command, whoami, is going to give us the name of the current user, and then the pwd command is going to tell us what directory we're in currently. So if we run this with the double ampersand over here in between, it's just going to run both of these back to back. So we are the root user, and we are in the root directory over here. That's what's reported. Remember, if you have any questions about any of the commands that we're using, please type in the chat, and I'll try to answer your questions as best I can and as soon as possible. Another good resource for learning about any kind of Linux commands is ChatGPT. So I ask ChatGPT all sorts of questions about Linux, because I keep on forgetting a lot of stuff, and unless I'm running a command over and over again, I usually don't remember the specific commands. And I think you can use ChatGPT without an account. So everybody, this is just a great tool in general. So if you just want to learn about any old topic, you can ask ChatGPT any questions you might have about Linux. Okay. So that was the double AND operator. So next is this operator over here. This is the greater than operator. So this is going to take the output of a command and redirect it into a file. If there's already a file with the same name in the directory, it will be overwritten. So this is actually a great way we can create files inside of Linux. So over here, what we can do is we can use the echo command to echo something out. For example, in between these double quotes over here, I can put this is a new file, HackerFrogs rule. Okay, and then what we can do after this is we can redirect this into a file. So we're going to use the greater than symbol, and the greater than symbol is the shifted version of the period on your keyboard, and we can redirect this into some file name. So I'm just going to call this message.txt. And if we issue this command over here, we're going to see that this message.txt file has been created in our directory. So if we use cat to read that message, we should see this is a new file, HackerFrogs rule. Okay, so everybody, what I want you to do is I want you to try this out. So I want you to use the echo command and then a couple of double quotes, and in between the double quotes you can put anything you want. Anything you want. And then what I want you to do after that is I want you to use the greater than sign and then space, and then I want you to make something like test.txt. Okay? So give that command, and then I want you to cat read the file that you just created, okay? So just like this. So everybody, I want you to try this out. If you have any questions or if you're having any difficulties, please let us know in the chat. But if you're able to echo out something and redirect it into a file and then read the file, please let us know by typing in the chat, I made the file and read it, with some smiley faces. Okay, we've got some people coming back and they made the file and read it. That's great. That's what I like to hear. Okay, great. All right, so let's move on. But actually, one more thing before we move on. I wanted to point out that say we have our test.txt and we read this. It says anything you want. If we do the same command, but we make it something else, then we read the test.txt, we see that anything you want has been overwritten by something else. So this is something we need to keep in mind when we use this single greater than symbol over here. Okay. So next we're going to talk about the double greater than operator. It works in a very similar fashion to this previous operator, but if a file with the same name exists in the directory, the output will be added to the file instead of overwriting the file. So if we wanted to take some notes inside of Linux, we could very easily use this method over here. So what we would do is say I wanted to create some notes. So I'm going to echo something, and I'm going to echo it out to notes.txt. So let's say my first note is I need to buy some milk. Oh, we need to use the double greater than operators here. So if we use the double greater than operators and the file already exists, that means it's going to add on to the file instead of overwriting it. So if we run that and then we look at notes.txt, I need to buy some milk, okay. But if we wanted to add something else to notes.txt, say we wanted to add, I also need to buy bread. Then we can read notes.txt and see that this has all been added to the file and it hasn't been overwritten. Okay, so this is a very useful way to redirect output and start adding to these files. And this is actually how sometimes I take notes inside of the Linux terminal by making files just like this. All right, so what I want you to do is I want you to try, and remember you can bring up previous commands in the console by using the up and down arrow keys. So just do up and down inside of the console, and that's going to bring you back to your previous commands. You can also use the arrow keys on the right and left arrow keys on your keyboard to move around inside the terminal here. So what I want you to do is I want you to create your own notes.txt file, and I want you to use the double greater than along with the echo over here to start making a file with multiple lines. This is another line in the file, and then start adding that. So try adding 2 or 3 lines to notes.txt, and if you're able to do so, please type in the chat, I can make a multi-line file. Okay, so user PK says, I need the link. And I'm going to provide the link. Here you go. So we're going to echo something, something, and then use the double greater than symbol and then space, notes.txt. Okay, so some people are doing it. They're making the multi-line file. Thank you very much. Nice to see. Great, great. Okay, so let's move on to the next step. The next step is to do the touch command. So the touch command is used to create empty files with the name specified in the argument. So if we just want to make an empty file, we can do the touch command over here. So it may seem a little bit strange to just create an empty file, but sometimes we would just want to create an empty file. So we can do touch and then some file.txt, and then we see that this file has been created inside of our directory. So most of the time you don't really need to use the touch command. Most of the time you're going to use some other method to create the file, but just be aware that you can use the touch command to create an empty file very easily in the Linux console. Okay, so next. So the copy command, otherwise known as the CP command, it's going to copy files from one directory to another. The first argument is the file to be copied, and the second argument is the directory the file is to be copied to. So this might seem a little bit confusing, but let's do a little bit of demonstration. So over in our directory, we're going to make a new directory just so we can demonstrate this. So we're going to mkdir, and we're going to call this directory test underscore directory. So we've got our test directory over here. And what we want to do is we want to copy test.txt over to the test underscore directory. So what we want to do is we want to use the copy command. So first thing we provide is the name of the file that we want to copy. And the second thing we want to provide is the directory we want to copy it to. So if we do cp space test.txt space test underscore directory, after we give this command, and then we do ls on test underscore directory, we're going to see that the test.txt file has been copied there. So what I want you to do is I want you to give this a try. So first of all, make a directory. It doesn't matter what the name of the directory is. Then I want you to copy some file that's in this directory. So for example, if you have the notes.txt file, you could do cp notes.txt and then space and then the destination, which is test directory. Go ahead and give that a try, and then if you ls the directory you just copied to, you should see that the file that you copied is in there. So give that a try. If you're able to do that successfully, just type in the chat copy, copy, copy. Smiley face. So one more time, it's CP for copy, and then the name of the file you want to copy, and then space, and then the directory you want to copy it into. Just like that. Okay, so some people are managing to copy. If you're having some trouble, let us know what error message you see, and then we can try to help you, okay? Remember, anytime there's too much clutter on the screen and you want to clear off the terminal and go back up to the top, you can just use the clear command. So just type clear, hit enter, and that should clear off the terminal and then send you back up to the top of the screen. Okay? All right, so some people are copying. That's great. Let's go over to our next little concept. So we just did the copy command, and next we're going to take a look at the move command, MV. So the move command is used in a very similar fashion to the copy command, except that the original file will not remain in its original directory. It's going to move, and so that means that it's not going to be in the original directory that it came from. This command is also used for modifying the names of files. So let's demonstrate this. So here we've got, let's say we're going to make a new directory called move_dir for a move directory. Okay? So we want to move the notes file over to the move directory. So we're going to do mv for move, notes.txt for the file we want to move, and then we're going to move it into move_dir for the directory we're going to move it to. So if we run the command, we're going to see that the notes.txt file is no longer in this directory. And then if we do ls on the move directory, we're going to see that the notes.txt file is in the move directory now. Okay, so let's give this a try. So one more time, whatever file is in your directories, say we want to create a new file to move. We're going to do touch and then move.txt. So if we wanted to move this move.txt file into the move directory, we would do mv move.txt move directory, and then we do ls move_directory dir. We see that move.txt was moved. Okay, so maybe we don't need to demonstrate. We don't need to. You can go ahead and give this a try while I demonstrate the other common thing we use the move command for, and that's to rename something. So let's say I created a new file called something, but I misspelled this. So I put an extra a onto this file called something but I actually want to rename this. I want to call it something.txt. So we can use the move command to rename this file. So it's going to be move and then something a, which is the original file, and then we're going to rename it to something.txt. So when we execute this command, this file is going to be renamed from something a to something.txt. So when we do this, we're going to see that something.txt is now here, and something a doesn't exist anymore. Okay? So what I want you to do is I want you to, let's say we're going to create something called misspell.txt. Okay? So touch space misspell.txt to create the empty file called misspell.txt. What I want you to do after that is I want you to try renaming it. So it's going to be mv misspell.txt, and then we're going to rename it to corrected.txt. So let's give this a go. So if you're able to use the move command to rename something, please let us know in the chat by typing in, I renamed the file. Smiley face. So you can see here that corrected.txt exists now, and misspell.txt was removed because it was renamed. And as usual, if you want to clear off your terminal because it's getting a bit full, you can just use the clear command. One more time. So say we wanted to rename this message.txt file, and we want to turn it into a file called, I don't know, something else, or rename.txt. We could do mv message.txt, and then the new name, rename.txt. So message.txt is going to be renamed into rename.txt. Okay. All right, so let's move on to the next thing. So we're going to do a little picoctf challenge right after we learn about the next thing, which is the help flag. So the help flag can be used as part of any command to return a relatively brief explanation as to how to use the command. So in a modern environment, we don't really use the help flag anymore, but it's useful to know that this is still here. Most of the time when I need to learn about how to use a command, I just go to ChatGPT or I go to Google and I Google how to use the command. But sometimes we don't have access to the internet, and in this kind of situation, it's useful to use the help flag. So what we do is -- help with the name of the command we want help with. So over at our console, say we wanted to know how to use the ls command, we could just type ls and then -- help. And then when we do that, it's going to give us a document about how to use the ls command. So ls, you can actually get a lot of different output from the ls command if you use some different options. And these are the options over here. So you got your -a, -b, -c, all sorts of different stuff. But the way you see this document over here is you do the command and then space and then -- help. So you can use your mouse wheel to scroll up and down inside of this output over here. But I don't want to see all this, so I'm going to just use the clear command. And then we can go back up the top. So just like this. Okay. So you can do this for any command actually. So you can use cat -- help and see the help document for the cat command. And you can also do the help flag for who am I. So this one's actually pretty easy. The who am I command, there's not very much to know about this command because it just tells you who you are. So if you do who am I -- help, all it does is it tells you that it prints the username associated with the current effective user ID, just like this. So there's not very much going on here. But for some commands, you can get a lot with the help flag. Remember, one more time, it is whatever command you want, say cd, and we want to get the help command for that, and then space, it's going to be -- help. So even for CD, there's a lot of extra output you could potentially get for the CD command. I actually don't use any of these when I use the CD command, but oh wait, I didn't use CD, I used ls. Sorry about that. Wait, I did do CD. It's just down here. Okay. All right. So I'm going to go back up at the top. Okay, so let's do a little challenge in picoctf, okay? So over at picoctf, and remember, if you don't have an account over at picoctf, you can, let me grab the link for registering for picoctf. Picoctf, register. If you don't have an account at picoctf, you can register for an account over at this link. So just create an account and then you can follow along with us, okay? But for everybody else, please log into your PicoCTF account and we're going to do a challenge. So we're going to do the PicoCTF Wave a Flag challenge. So we're going to practice some of the commands we've been learning with the following challenge over here. I'm going to grab the, I'll get the link for the challenge in just a little bit, but the first thing we need to do is we need to open up our PicoCTF web shell. So inside of PicoCTF, go to the practice page, and then after you go to the practice page, scroll down a little bit, and then click on this button over here labeled web shell. So it's going to start up a Linux session over here inside of the web shell. And what you want to do is you want to go to this button over here labeled Pop Out Web Shell Terminal. So just click on that one. And what it should do is it should create a PicoCTF web shell that's nice and big inside of another web browser tab. So sometimes this doesn't work. If it doesn't work, what I want you to do is I want you to close the web shell and then go back to your PicoCTF page, click on the web shell, and then I want you to try again. Click on the Pop Out Web Shell Terminal button. And then it should, so it might take 2 or 3 tries, but eventually you should be able to get your web shell working just like this. So if you get the web shell running, then you should see this output over here, nice and big in another web browser tab. So everybody, if you manage to open up your web browser, your web shell nice and big, please type in the chat, web shell ready. So in the meantime, I'm going to grab the link for the challenge, which is over here. And everybody, this GitHub page over here that I'm going to provide in the chat, it has all of the links for the challenges we're doing for today. You can take a look at that if you like, but otherwise you can just click on this link after you've logged into PicoCTF. And this is the Wave a Flag challenge. So we see here that this is the Wave a Flag challenge, and it asks us, can you invoke help flags for a tool or binary? This program has extraordinarily helpful information. Okay. All right, so user AW says they don't see the web shell. Okay, so let me demonstrate one more time. So after you've logged into the PicoCTF website, I want you to go over to the practice page. So there's going to be this menu over here. Just click on the word practice and then scroll down a little bit. Then click on this button over here. So on the right-hand side of the screen, you're going to see this button labeled Web Shell. Just click on that. And then this is going to report that this is the welcome to the PicoCTF Web Shell. So we don't want this because this is very small and we can't actually see the rest of the information on this page. Click on this button over here called Pop Out Web Shell Terminal. And then that's going to put the web shell in its own browser tab in your web browser. Okay? So user AW, I hope that helps you, and I hope you're able to follow the instructions and see the big web shell. But if you're having more problems, please let us know. Otherwise, everybody, if you manage to open up the web shell, please type web shell ready in the chat. Thank you. Let me go back to this page. Okay, so to start this challenge, what we need to do is we need to download the program that's associated with the challenge. So the words "this program" is actually a link. So what we need to do is we need to mouse over the link and then right click and then select copy link. Sometimes it'll say copy link address, it depends on the browser, but it's going to say something like copy link after you right click on it. Select that and then go over to the web shell. And if you don't interact with the web shell for a little bit, it's going to close. So it says press enter to reconnect. So we just need to press enter to reconnect to the web shell. Okay, so what we're going to do first is we're going to create an environment for solving this challenge. So we're going to do mkdir to make a directory and then space, and we're going to call this wave a flag. So remember, we can't use spaces in our file names because otherwise bad stuff is going to happen. We could use underscores instead of spaces. So let's make the directory wave a flag, and then let's enter the directory with the cd command. Remember, after you start typing a file name, you can hit the tab key on your keyboard to autocomplete the file name. So after we've entered our wave a flag directory, we can use the wget command to download a file. So it's going to be wget and then space and then right click and then select paste. So you should see the file address be pasted in over here. Just hit enter after this and you're going to download the file. So this is called warm. The file name is called warm. If you do ls after you download the file, you should see that this file is in the directory now. It's called warm. So if you manage to successfully download the file, and when you do ls, you see the warm file in your directory, please let us know by typing "I got the file" smiley face in chat. Okay, nice to see some people have downloaded the file. Like I said, if you're having troubles, please let us know. I don't want anybody to be left behind in the class. So if you're having troubles downloading the file, please let us know and we'll try to help you out. All right. So what did the challenge ask us to do? So it says, can you invoke help flags for a tool or binary? Does anybody remember what we have to run with the command to get the help? It was something help. Dash dash. That's correct. Whoops, I went to the wrong place. Okay. No, we need to go to the web shell. Here we are. Okay. So if we run this warm file over here, and we can run this by, I don't know if we can just type the word warm and then do dash dash help. Yeah, so this is not a command inside the system. What we want to do is we want to run this file. So actually, here's something interesting. So we can't actually execute files unless they have the execute permission. And you can see if a file has the execute permission inside of the ls-l output over here. It should have an X over here if we can execute it. But we can actually make the file executable by adding the execute mode to the file. So we have to use another command called chmod and then space plus X for executable and then the name of the file, just like this. So after that, you should see that inside this, when you do ls, you should see that the file has become green, and that means it's an executable file. So to execute this file, we have to reference this current directory, and we can do that by doing /. So // is the directory we are in, and then type warm. So it's going to be /warm. So it says, hello user, pass me a -h to learn what I can do. So all you need to do to solve the challenge is to run the warm program with the -h. So if you're able to do so, it's going to give you a flag over here. And if you got the flag, please type in the chat, I got help. But if you're having some trouble, please let us know what error message you see, and then we'll try to answer your questions and help you out, okay? So to finish the challenge, all you need to do is copy the flag over here. So just highlight it, and then right-click, select copy, then go over to the challenge page. And in the challenge page, there's this section over here, which is for submitting flags. Click on it. Use the you can right-click and select paste, and that's going to paste the value of the flag. Click on submit flag, and then you should be done. So in this case, it seems like the server isn't responding. So we just need to wait. And yeah, the server did not respond. So if that happens to you, you can just wait until the error message pops up and you can try again. It didn't work again. Let's try one more time. Okay, this time it worked. So if something doesn't happen and you get an error message, you can always try again. And maybe try it a few times, and you should be able to get it after a little while. Okay, so we'd finished that challenge. All right, so let's learn a little more before we do our last challenge for the day, okay? So over here, we're going to learn a little bit about the file permissions. So we learned a little bit about file permissions in the last challenge, but what I want you to know is that each file in the Linux file system has different read and write and execute permissions, depending on whether a user is 1. The file user, 2. Part of a certain group, or 3. Any other user. So file permissions, you don't need to know all that much about file permissions, aside from the fact that there's something called read and write permissions. Read means you can read it. Write means you can modify the file or delete the file, I think. And X for execute means that you can run the file. So the three permissions are read and write and execute. So this is what these letters are when you do the ls-l command. So in JS Linux over here, we do ls-l, and we see that there are all of these files in here, and each one of these files is going to have different file permissions. So for example, this one right here, this HackerFrogs directory, it's got, so the first 3 letters, so this D here just means that it's a directory, but the first 3 letters after that are for the file owner, and the file owner is the first name over here. So the file owner here is root, and these are the permissions for the file owner. The next 3 letters over here are the permissions for the group, and this is the name of the group over here. And the last 3 letters over here are the file permissions for everybody else on the system, which means that any other user that's not this user over here. So, like I said, as a regular Linux user, you don't need to know too much about file permissions, aside from the fact that if you're a user on a Linux system, you have access to your own files in your home directory, and you usually don't have access to other users' files and directories. So next we're going to talk about the switch user command. So usually on Linux systems there are a bunch of different users, and we can actually switch between different user accounts using this su command. Su for switch user. So what I want you to do is I want you to go over to, oh, this isn't what I wanted. Next page, please, over here. Okay, so what we're going to do is we're going to use JS Linux to create a new user inside of the JS Linux, and we're going to practice switching over to that user. So over on this page, I want you to click on this link, and on this link there's going to be a section at the bottom called Making a New User in JS Linux. So we've got some different commands here, and what these commands do is that it creates a new user on the system called HackerFrog, and the HackerFrog user's password is going to be this over here, frogpass. So what you need to do after you click on that page is just go down to the Making a New User in JS Linux section, and then you want to click on this button over here. So on this side, there's this button over here. It looks like two boxes. Click on it, and then it'll say copied. After that, go over to JS Linux. And at JS Linux, I want you to right-click and select paste.
Hack the planet! Hack the planet!
Somebody from YouTube is hacking the planet. Thank you very much, Zohai Basan on YouTube. So just right-click and select paste, and that's going to paste in all the commands that we just copied. So after that, just hit enter. And that's going. These commands are going to create a new user inside the Linux system. Okay, this might take a little bit of time to execute. Okay, and then after that, to check that this command actually went through, I want you to cat the /etc/ the password file. So this this word password is misspelled on purpose. So it's just cat space /etc/passwd, and this is actually a file on the Linux system that tells you all the different user accounts on the system. So if you run this command, you should see at the bottom here. So these are all of the different user accounts on the system. Most of these are not actual users. Most of these are program accounts. So different programs in the system need access to the Linux. They need a user account to be able to interact with the system. So that's what all these are. But then at the bottom, you should see that the HackerFrog, the HackerFrog user has been created at the bottom of the file over here. Okay? So if you manage to go to this page and copy the commands, and then go over to JS Linux, paste in the commands, and then you were able to see that the HackerFrog user has been created, please let us know in chat by typing in, "I made the HackerFrog." User M says, it says no such file or directory. Okay, so if you're getting that error message, what I want you to do is I want you to just type in cat. So what command did you, user M, what command did you do to get the error message no such file or directory? Was that the cat /etc/password command, or was that the okay, so cat /etc/passwd. So this isn't the word password, it's the word passwd. So give that a try. So if this file doesn't exist on your system, that would be very interesting. Because all of the Linux all of the Linux systems have this file. So once again, I'll type out the command in the chat. It's cat etc/passwd. Okay, so it looks like some other people are successfully creating the account. So if you're having trouble, let me demonstrate one more time. I'm going to reset this box. So just go over to, let me check that this is reset. So at any time, if you want to reset the your Linux machine over at JS Linux, you can just reload the page. The one thing you need to keep in mind that when you're reading the etc password file, you have to put the slash in front before you read the file. So it's /etc/password. Okay. So let me demonstrate one more time. Go over to the GitHub page, making a new user in JS Linux. Click on these two boxes. So down here, there's this making user, new user in JS Linux. Click on the boxes over here. It says copied. Then go over to the JS Linux. Right click and select paste. And then hit enter. It's going to take a few seconds. After that, cat the /etc/password file, and you should see the HackerFrog user has been created. Okay? So now let's become the HackerFrog. Let's become the HackerFrog now. So remember we were talking about the SU for switch user command over here. SU lets you switch users. So at JS Linux, SU HackerFrog. So switch user to the HackerFrog. Hit enter. And it should switch your user account over to HackerFrog. So it says HackerFrog at localhost now. And if you ask, who am I? It should say that you are HackerFrog. Okay, so here's an interesting thing. After you become the HackerFrog user, if you tried to type ls, it's going to say cannot open directory, permission denied. And do you know why? So the reason why we can't read the current directory is because we're in the root directory and we don't have permissions to read the root directory. So that's why we can move into the HackerFrogs home directory. And to move into the HackerFrogs home directory, we just need to do cd by itself, hit enter, and then we are in the /home/HackerFrog directory. Okay? So everybody, if you managed to become the HackerFrog, please let us know in the chat by typing out, I am the HackerFrog. Okay, so some people they managed to create the HackerFrog and become the HackerFrog. Okay, nice to see, nice to see. Great, great. Okay, so we're running out of time for today's session. So what we're going to do is we're going to move into our summary for today's session. So we actually learned a lot of different commands. There were a couple more commands that we were supposed to learn. We were supposed to learn about Linux file directories and some other stuff, but we might be doing that in the next session. Okay. So, but we learned a lot. So let's go over to our summary. Let me reload this page. Let's do page 25. all this different stuff. Where were we? So we learned about a lot of different commands in today's workshop. So we learned about the help flag, which is part of any command. We can use it to return a relatively brief explanation as to how to use the command. We learned about, well, we didn't learn about the manual command, but this is basically a more complicated version of the help command. It gives you a lot of documentation about different commands. We learned about the AND operator, which we can use to execute a command as a background process. And we learned about the AND operator to execute two commands to the left and right of the operator, one after another. We learned about the greater than operator, which we can use to redirect output into a file, and the double greater than operator, which is kind of the same thing. We learned about the touch command, which is used to create empty files, the CP command to copy files, the MV command to move files, the RM command. I think we already knew about the RM command, but just really quick, you can use the RM command to remove files. So if we make a file, we can delete it with the RM command. So it's RM and then the name of the file, just like that. And we learned a little bit about Linux file permissions. So everybody, what we're going to do is we're going to be finishing up the class in just a bit. To everybody on the live stream, we're just going to go to a "be right back" message while we finish off the class in Zoom. Okay, so for everybody on the live stream, we'll be back in a few minutes. Okay, everybody, we're back. All right, so I hope everybody had fun learning about Linux OS operations in the previous section of the stream. What we're going to do is we're going to shift gears and we're going to go into a new topic. But we're going to be doing another class in about an hour or so. But we've got a bit of time between now and then, so what we're going to do is we're going to be doing some hacking. We're going to do a little walkthrough for a challenge on the Volnix website. So first of all, let me change my Let me change my overlays a little bit. So the next HackerFrogs class we're going to do in about an hour or so is going to be the Python programming course. And that's going to be for the second session. So HackerFrogs Python 2. So that's, let me adjust the text over here. Okay. So in the meantime, what we're going to do is we're going to hack against the Volnix website over here. And to anybody who doesn't know, Volnix is over here, and I'm providing it to everybody in chat. It's a website where you can download virtual machines and you can hack against them. And the demonstration we're going to do today is for, which machine is it for? Let me go down in the list. Was it Doctor? Was it Shock? It was Real, this one right here. So this is machine number 16 on the list, and we're going to be hacking against that. So to start, what I need to do is I need to start the machine up on my virtual machine network. So we're actually working off of a virtual machine right now. What you see on the screen right now is my Kali Linux virtual machine. And what we need to do is start up our challenge machine, which is called Real. So I'm just starting it up in VirtualBox over here. So these machines are running on the same network, and that's how we're accessing them. So what is the IP address? So the IP address that we need to attack in this case is going to be 10.0.2.28. So we need to remember that. All right, so without further ado, let's dive into this challenge. It is called Real, and let's start with some Nmap scans. So inside of my terminal over here, we're going to run Nmap, and we're going to scan all of the ports on the target machine, and we're going to be running it in very verbose mode, which means that we're going to get output immediately when we run the command. We're also going to be running it on 4 threads, which means the scan is going to go very fast, but not too fast. So let's do that. Okay, so the results come back very quickly, and we see that there are 1, 2, 3, 4, 5 ports open on the system. So we've got port 80, which usually runs port 80, which usually runs HTTP. Actually, let's go down this list. So we've got port 22 open, which is running SSH. SSH is what lets us log into different remote servers. We also have port 80, which runs HTTP, which is web pages. We've got 6667, 6697, and 8067, which are all different versions of this IRC service. So IRC is Internet Relay Chat. It's something that people used to use a long time ago. I think people still use IRC, but it's very uncommon these days. And it was the earliest version of Internet chat that a lot of people used. Okay, so what we're going to do next is we're going to run another Nmap scan to further enumerate the system. So in this case, let me clear the screen so we can go back up to the top of the terminal. In this case, we're going to do the same Nmap scan. Hold on. I forgot to take a note of these port numbers. So what we're going to do is we're going to run another Nmap scan, but we're going to specify the port numbers. So we've got these ports over here. So at this point, -P is going to be the specific port number. So it's going to be 22 and 80 and 6697 and 6667 and 8067. So at the beginning of this command, we're also going to tack on -SC for common scripts and -SV for versioning information. So after we do this, we're going to run the command, and we're going to get more output from this particular version of the this particular syntax for the nmap command. So we see here that on port 22, it's running OpenSSH at version 7.9. So this is a relatively up-to-date version of OpenSSH, which means that this software is probably not vulnerable to any known exploit. And we have port 80. We've got our Apache server. Our Apache server running at version 2.4.38. This is probably not vulnerable either, but we could check if we run out of things to do. All right, and we also have these 3 ports over here, which are running Unreal IRC-D. So this is the version of IRC that is running. It says admin email example at example. Okay, so basically what we need to do is we need to figure out how to, because we've got these 3 IRC ports, we should probably learn how to do security testing against the IRC service. So whenever I run into a new service that I haven't encountered before, what I like to do is I like to go over to Hacktricks. So that's going to be at Hacktricks, book.hacktricks.xyz. And to anybody in chat who hasn't seen this before, I'll just provide a link to this website. So this is Hacktricks. This is Hacktricks, and it's a very good resource for learning how to do hacking against various network services. So the Hacktricks website was created by the same author who created the WinPs and the LinPs privilege escalation checking scripts. So you know this person probably knows their stuff. So inside of the Hacktricks website, we can go over to the search bar over here, and I can type in the name of the technology that I want to try testing against, which is IRC. So over here, we see that there's an article here called Pen Testing IRC. We can click on that. So we'll just wait for it to load up over here, and we get some information about pen testing against this protocol. So IRC, initially a plain text protocol, was assigned 194 TCP, but is commonly run on 667 TCP and similar ports to avoid needing root privileges for operation. So ports that are under a certain number require root privileges for operation. So I guess that's why they reassigned the port number, in this case, to 667 and above. So let's see. A nickname is all that's needed to connect to a server. Following connection, the server performs a reverse DNS lookup of the user's IP. So how do we do enumeration on the system? So what we can do is we can use netcat. So netcat with the -vn for verbose and no DNS lookup on the IP number and the port. So let's try that. So what we can do is just grab netcat with the VN. I guess we don't need to copy it, but over here, we're going to try running netcat against this IP address, and we're also going to specify the port number, which is 6667. Okay, it says looking up your hostname couldn't resolve the hostname using your IP address instead. So, all right. So now that we got the, actually, we didn't actually receive a banner, but we did manage to connect to the service on port 6667. So what else can we do? So we've got the manual. Here you can see how to connect and access the IRC using some random nickname, and then enumerate some interesting info. You can learn more about the commands of IRC here. So let's see. So first of all, we can try logging in as a user with this name, and a username with this, and a nickname of this. I'm not sure what the difference is between the nickname and the username, but we can try doing exactly this over here. So this one got closed, but we can try logging in and giving this command, and we can see if it actually lets us log in. So this is taking a little while to come back. So maybe we can't communicate with this particular, on this particular port. We could try another port. So let's try another port. I need to be reminded, so it's 6667, 6697, and 8067. Okay. So let's try 6697 instead. So we're going to do the same thing, but on NC 6697. Okay. Matt from Space on YouTube says, you found a new sub. I found a new sub. Is it you, Matt from Space? All right. So it looks like we're now connected on this port. Let's copy this command and try to log in on this port. So I'm not sure if it should be giving me output after giving this this username and maybe a password. I'm not sure. Matt from Space, thank you very much. Thank you very much for subscribing on YouTube. Happy to see. Happy to see. Okay. Okay. So maybe this port isn't working either. So we're going to try the last port. So the last port is going to be 8067. 8067. So let's run it on that. And let's try logging in using this command over here. So I don't know what the normal output from IRC is. So it could be that we're actually being logged in. We can try help. Helps, it says you have not registered. Okay, so we have to register. Is registering this one right here. Let's try this command. Okay, so after giving this command, we are now logged in. So it says your host is irc.funat.com. Running version is Unreal 3.2.81. So this is a very specific version of Gabriel? I'm not sure. But thank you very much for subscribing with YouTube. And we haven't done a redeem in a while, so let's do a redeem for Hack the Planet. So there are a lot of different little video redeems.
Hack the planet! Hack the planet! Shut up and get in.
And one of them is Hack the Planet. There's a bunch more. I think there's... What was the command? So there's Hack the Planet, and there's a bunch of them. We'll look it up a little bit later. But yeah, so we've got this version of Unreal IRC server 3.2.8.1. And I get the sneaking suspicion that because IRC is a very old protocol that's not used very much anymore, that there's probably some sort of exploit that's available for this version of software. So we're just going to copy this, and then we're going to exit. Exit is an unknown command. Okay. And we're going to search this up on SearchSploit. So it's Unreal with this version right here. And let's see if anything pops up looking for exploits on SearchSploit. So over here, we see that there is a backdoor command execution exploit, and there's a local configuration exploit. There's a bunch of different exploits. Okay. Maybe I don't want to use Metasploit, but I still want to look for this kind of this I don't want to use Metasploit because that means that I'm going to have to use Metasploit framework, which is kind of a pain in the butt. So what I'm going to do is I'm going to look up this exploit on Google. So over on Google, look up this version, Unreal 3.2.8.1, and then exploit. And then we see that there's this GitHub page over here. And this GitHub page over here says, this is a Python version of a Metasploit module that exploits a known vulnerability in Unreal IRC D 3.2.8.1. Okay? So Matt from Space says, I just sent a link to your channel to a cybersec group I know. Since I like people who teach and learn to exploit vulns, it's not easy. Oh, thank you very much, Matt from Space. Thank you. Yeah, so I'm usually on Mondays, Wednesdays, and Fridays, and we usually like to do a couple of CTF boxes in between doing teaching. So I'm currently teaching Linux, how to use Linux for beginners, and how to use Python for beginners right now. But we also do hacking against CTF boxes like this. But much appreciated for spreading the word about this channel. Thank you very much, Matt from Space. Okay, so what we're going to do is, it says the updated version of this code has the ability to select the type of reverse shell to be sent. Currently there are only 3, Python, Netcat, and a bash shell. These options are set with payload -payload. For example, Python 3 exploit -payload Python. All right, so what we need to do is we need to download the exploit Python file. So first of all, if you want to have access to the Python file that I'm looking at, you can look at it from the following link. And what we're going to do is we're going to... Oh, Matt from Space also says, hopefully you can get more subs. I'm a Linux power user, but I've been needing to get back into this space. I'm better at terminology. Oh, okay. Yeah, no, you probably know how to use Python better than I do. So sorry, I mean Linux. You probably know how to use Linux better than I do. I basically only know the commands that I normally use to run these CTF challenges, and I actually am very, very weak as far as administrator commands are concerned. So I don't know how to create new users, and if I want to do any sort of administration actions, I usually have to ask ChatGPT for the syntax for those commands. Okay, so let's go over to exploit.py, and we can take a look at the script over here. Actually, we can look at it in its raw form. What I like to do, just to make sure that there's no sneaky code in here that's going to compromise my system, is I like to do a little code review with ChatGPT. So I'll just go over to ChatGPT and I'll ask it, I'm planning to run this script as part of a CTF challenge. Is there anything dangerous for my host system in here? Okay, so I'll just ask this question, paste in the code, and then ask the question. So what does it say? Your script is designed to send reverse shell payloads to the target machine as part of a CTF challenge. There are a few things to consider. Okay, reverse shell vulnerabilities. So I guess what this is trying to demonstrate is that if you open up a reverse shell listener on your own system, then someone could potentially reach out to your system before you receive the reverse shell from the target system, which could be dangerous in such a case. In this case, it's not dangerous because we're not our systems aren't exposed to the internet. They're only exposed to each other, so it should be okay. So I looked this over previously, and there's nothing really dangerous here, but it is a good practice to review any script that you get from the internet before you run it on your own system, just in case there's something dangerous that the writer decided to sneak in there. So what we're going to do is we're going to go back to our console. I'm going to enter the temporary directory, and then I'm going to create something called, I'm going to name this script irc_pwn.py. So I'm just going to create that using nano. And Matt from space, actually, here's one thing that is probably different between you and I. I like to use nano as my in-terminal text editor, but I'm sure you probably use either Emacs or Vim as your regular text editor inside the terminal. But I hear that some people are very passionate about which terminal text editor they use. So I'm going to paste in the code, and I'm going to take a look at whether or not I need to supply any arguments. I need to change any variables, rather. So in here, I see that down here, there's a local IP port, there's a local IP address, and there's a local port, and there's probably... Okay, so it looks like Matt from Space says, I like to use micro as it's in between Vim and Nano, but I can do all the ones you said. Okay, that is, well, micro, I haven't really heard of micro, but yeah, most people who are very serious about their Linux, they learn how to use multiple text editors. I only know how to use Nano properly. I know how to use, the only thing I know how to do in Vim or Vi is to save a file and to write. The only thing I know is how to edit things and to exit. So learning how to exit from Vim took a while, but I'm sure there are all sorts of jokes to be made about that. Okay, so I need to get a local IP and a local port over here. So what we need to do is we need to prepare a reverse shell listener. So what we're going to do is we're going to go over to another tab, and in our other tab, we're going to start up a netcat listener. So netcat, and then NLVP, and then 443, because we don't like to supply strange ports like quad 4 or quad 8. This netcat listener is going to listen on the attacker system and on port 443 for any incoming connections. So Matt from Space says IP-A gives you an IP in Linux. So I actually haven't. I'm not familiar with using the IP command in Linux. Most of the time, I just use the ifconfig command, and that usually gets you a lot of. That probably gives you more information than you need. But for this interface right here, we're running our attacker machine on this IP address 10.02.22. We need this. We need to supply this to the script. So over back at the script, we're going to supply the local IP, which is 10.02.22, and we're going to supply the local port, which is 443 in our case. IP is the old school. Oh, I didn't know that. I thought ifconfig was the older command and IP is the newer one. But I guess IP is the older one. And thank you for that little piece of trivia. All right, so we've adjusted the script, and I think this is all we need to do. So we're going to save and exit. So Briz Zay has just subscribed on YouTube. Thank you very much, Briz Zay. All right, so let's save out the file. Control X and then press Y and then hit the enter button, and that's going to save out the exploit script. So the exploit script is irc_pwn.py. So we're just going to run Python and then irc_pwn. And then what we need to do is we need to supply the IP address of the target machine as well as the port that IRC is running in, as well as our own IP address over here. And the last thing we supply is the port that our netcat listener is supposed to be listening on, or where we want to catch our reverse shell rather. Matt from Space says, my ADHD is kicking in, but I remember it doing ifconfig ifconfig, okay, is equivalent to IPA. So if we do, let's just do a quick demonstration. IPA. Okay, so this actually looks IPA. Does the A? So on this terminal, this color highlight is very useful. So it tells us our IP address and the type of network that it's on, which is /24. That's very useful information. So actually, I might use IPA instead, depending on because it seems, well, especially if I can get color highlight on my output over here. So okay. All interfaces is, yeah, the A, right, okay, that's great. All right, so let's run this exploit. So we're running the exploit. We specify the IP address of the target, as well as the port that IRC is running on, and then our attacker machine IP address, and then our attacker machine port. So let's see. Oh, we need a payload. Okay. So payload is either Python, netcat, or bash. Let's try netcat. So we're going to do -payload, and then we're going to use the netcat payload. Okay, let's try running that. I guess we don't need. I guess in this case we don't need the we don't need this output either because we supplied it when we edited the script in Nano. Okay, so it's Python, the name of the script, the target IP address, the target port where IRC is running, and then the payload, which we're going to specify as netcat. So we run this, and it says exploit sent successfully. All right, so if exploit is sent successfully, we should get a response over at our reverse shell. So let's check. So it says connect to this IP address. So this is our IP address from unknown, which is the target machine's IP address on this port. So if we ask who am I, it says we're the server. So I guess that's the name of the account. So first of all, let's take a look at the users on the system. So there's this. So we're acting as this server user right now, and we actually have a home directory, and we're using the default shell is the bash shell over here. So the user ID is actually quite low in this case, so I kind of suspect that that this user might have elevated privileges. So what we're going to do is we're going to do sudo -l to see if this user has any elevated privileges on the system. So we didn't get any response there. I wonder why. Okay. So we're going to try, what we're going to try now, because our terminal looks kind of ugly. We actually don't have much of a terminal, so what we're going to do is we're going to find out which Python version is running on the system, or which Python 3 version is running on the system. And then we can use this, we can use the Python program to upgrade our shell, our interface a little bit. So what we can do is use Python 3 and give it a command. The command is going to be import pty, which is the pseudo terminal module. We're going to end that command, we're going to do pty.spawn, which is a method from the pty module, which is going to let us spawn a sudo terminal, and we're going to do a bin bash terminal. And that lets us upgrade our shell a little bit. So one interesting thing about, so we could do all sorts of enumeration on the system. It's going to ask us for a password. I guess now that we have a better shell, we can actually answer these kind of this kind of input, but we don't have a password for this account. So what we can do is we can just do a little bit of snooping around. Sudo-L isn't going to list super users. Oh, no, I mean, I wasn't looking specifically for a list of super users. I was looking for whether or not the user had any sudo permissions on the system, sudo-L. But in this case, we need to provide a password to run that command, so we can't retrieve the output for that command, or we can't run it anyways. Let's see. Tupu on Twitch says I'd press Control C to quit the sudo and exit the shell. Well, I mean, we don't. I mean, I don't want to exit the shell completely. I just want to do some snooping around. So one interesting thing about this particular server is if we take a look at the permissions for, was it the permissions for the password file? Well, hold on, let me take a look. No. We can look inside of this opt directory here, right? So sometimes there's interesting optional software installed in the opt directory. And in this case, there's this file right here called task, and it's owned by root. So what we can do is we can get a little bit more information about this file over here. And it says that it's a born-again shell script, ASCII text, and it's executable. So this is an executable file. It's only executable by root. That's interesting. You know what? Let's take a look at the contents of the file. Okay. So this is a bash script. We know this because it starts with a shebang over here. And it defines a domain called shelly.real.nix. And then we create a function over here called check. So it's going to time out, and then it's going to do a bash command. So the bash command over here is user bin ping count1 on the domain. So it's going to ping out to this domain right here, shelly.real.nix. And it's going to redirect the output to dev null. So if what is this variable right here? If the variable echo is equal to 0, then it's going to run user bin nohup. Nohup. I actually don't know what this command does. What is the nohup command? We can look this up really quick. What is the Linux nohup? Okay, nohup in Linux stands for no hang up and allows you to run a command or script in the background, ensuring that it continues to run if the user logs out or if the terminal is closed. Oh, okay, so this script is running in the background. So this is probably running on the system right now. If that first way says, if I remember right, it doesn't show the output. Okay. All right, so it says here that, so I guess it's going to run in the background, it's going to run netcat -e, so it's going to do netcat execute user bin sh. So it's going to reach out to the domain, which is shelly.real.nix, on the port 65,000. And then it's going to exit, or it's going to exit. Exit 0 is with no errors, else it's going to exit with 1 error, right? So exit 0 is no errors, and exit 1 is with errors. I'm not, we can ask really quick. In shell script, what is the difference between exit 0 and exit 1? Oh, exit 0 indicates success. Okay. And exit 1 indicates general general error or failure. All right. Okay, so if it manages to connect with Netcat to the shelly.real.nix domain on port 65,000, then it's going to exit with success. Otherwise, it's going to exit with an error. Let's see. Tupu says, I thought it stored output in nohep.out at the user's desktop, or standard error maybe. So let's so we wouldn't be able to see that file because this file is owned by root. So even if the nohup.out file exists, it's probably in the root users directory. So we wouldn't be able to view it from here. So what this is checking for is it's checking if this domain exists, or actually it's not checking if the domain exists. It's just making a call out. Actually, it is checking. It's checking if the domain exists using ping, and if the domain exists, then it's going to try to contact the domain on port 65,000 using netcat. So what this is basically doing is it's sending a bind shell using netcat. So what we can do is we can add our own attacker machine as shelly.real. No, wait, we can create shelly.real.nix and assign it as our own attacker IP, and then that means that this script, if it's running in the background, it's going to reach out to our attacker machine, and because this is running as root, it's going to give us a root shell. So if we take a look at, I think I've already compromised this. So if we take a look, so first of all, here's something interesting about this particular machine, is that if we take a look at the /etc/hosts file, we see that the etc host file is writable. So this is a big no-no. You shouldn't let regular users write to the etc host file. But because this is writable, we can actually take advantage of this script over here, and we can have this machine contact us at our attacker machine. So what we would do is we can cat the etc host file, and I think I've already done this, and we've already added our shelly.real.nix domain as our attacking machine. But if we wanted to do this on the terminal, we could just do echo. Whoops. We would echo 10.0.2.22 shelly.real.nix, and then we would echo that out and do the double greater than signs to add on to the file, and it would be etc hosts, just like this. Okay, so what we do is we would add that using echo and add on to the etc host file. So because this has already been set, we can go back to our attacker machine, and then we can set up a netcat listener. So we're going to do a netcat listener on port 65,000. And then we wait for a response from the machine. So because the machine, we don't know how often the script is running. It might be running every minute or every 5 minutes. But over here, it says, let's see, Ghost Inc. says, sup, Ghost Inc., hello, nice to see you. All right, so what this is going to do is it's going to do netcat and contact our attacker machine because we've set the domain to our attacker machine IP address. And over here, we received a connection from the machine. And if we ask who we are, because that script was running as root, we are root. Okay, so we can redeem this fun video redeem message, video rather, and it is I'm root.
What are you?
I'm system root.
So if anybody's seen that movie, then you are officially old because that movie came out back in 1989 or something. But I'm not here to make fun of old people. I'm also old. But we are root now, which means that we would be able to access the root.txt file in the root directory. But let's see if, so the nohup file, I wonder if there is a nohup file. So one more time, I think somebody mentioned the nohup file. What was it? Nohup.out. Let's check if that file exists. So let's try find /name nohup.out. Okay. Matt from space. Okay, so well, not everybody's super old here. All right, good to see. But yeah, if you're a young person, if you're an old person, anybody is welcome here because we're all here to learn about fun computer system interactions. All right, so I guess we're not going to be able to read that. Maybe I should have run this as a background process, but maybe I wouldn't have been able to. Anyways, yeah, we are the root user, and we can access root.txt, which means that we've effectively finished the exercise. So, out of respect for the people, for the organizers over at the Volnex website, I'm not going to read the root.txt flag on the stream because they don't want people doing write-ups to do that. So we're going to leave this unread, but I guess we can call this a symbolic victory then. All right. So that's the end of that challenge. Thank you very much. Okay, so we've got a little bit more time before the class starts at the top of the hour. That would be 5 p.m. where I am, but probably some other time if you are in another time zone. So we're going to do. What we're going to do is we're going to hack against a different system. And so this machine I'm going to shut down. Okay. Yeah, that's victory. Thank you very much. Great. Actually, you know what? Here's another fun video redeem. And these are some Stellar Jays. And Stellar Jays are the West Coast Blue Jay bird. They're kind of like blue jays, except they have they're colored a bit differently. But these are really cute birds that come around to my bird feeder every day. But yeah, if anybody wants to know what these birds actually look like, and I take all of every opportunity to show these guys off. They're called Stellar Jays, and you can see this is what they look like up close. They're very cute birds. They act a little bit like crows and a little bit like blue jays, and they're pretty great. Nice birds, says Matt from Space. Thank you. But yeah, they're West Coast Blue Jays. So Blue Jays, you usually find them on the East Coast. They go to about as far east as the center of the country. But then from the Rockies onwards, I think you're only going to see these birds over here. Okay, so we got 10 minutes. Let's. So there's this system over here called Ready, which is the number one machine. Number one machine just means that it was published first. It doesn't necessarily mean that it's super popular or anything. But this is the machine we're going to test against for about 10 minutes before we start the next class. So what I need to do is I need to start this up on my network. And I don't know if... So just everybody who's out there, what command would you use to do a ping sweep of your /24 network? I'm going to do an nmap. So yeah, so this is the command I use with nmap to do a sweep of the network to see what machines are up. Oh, but you know what? I don't need to, because this machine tells us what the IP address is. Okay, so I guess I don't need to do that. But otherwise, we would do this command, and it would tell us what machines are up on our network. Tupu says that or a bash loop if available. Actually, there are a lot of different ways we could do ping sweeps, but yeah, but nmap is actually very convenient because it comes back. Well, if it's a network that that's not remote, then the results are going to come back very quickly. So we see here we've got our gateway, and then we've got our attacker machine, and then we have the machine that we're testing against over here. So, like I said, we always like to start our enumeration with nmap, and we do very verbose on all ports, on 4 threads, and then we supply the IP address. So, to anybody out there, I'm wondering, do you run Kali Linux, or when you're using when you're doing security exercises, do you use something like Kali Linux, or do you use another OS like Parrot OS, or do you just run something on Linux or Mac? So we've got a few different ports available here. We've got 22, we've got 8080, we've got 80, and we've got 6379. 6379, that's a bit unusual, but it reports that it's running Redis. So Redis, I think I've encountered this before. Tupu says I use Arch. I use Arch, by the way. That's you have to say by the way every time you say I run Arch Linux. By the way. Whonix? I've never heard of that. Devil Dog. I think I've seen you here before, Devil Dog. But Whonix, hey there. Whonix? Whonix. What is Whonix? Whonix. Superior Internet Privacy. It's a Linux distribution based on Kicksure OS, claimed to be security hardened by its developers. Interesting. Oh, okay. So this was created back in 2012. Huh. I've never heard of this. There's all sorts of stuff that I learn new stuff every day. So Whonix. I wonder if it has a bunch of cybersecurity tools installed in it by default, or if it's just about keeping your own stuff secure. Looks like Tails OS. Matt from Space says, I use Arch, but I ain't gonna go, I'm not gonna go nuts about it. Well, I mean, if you use Arch, the stereotype is that people who use Arch are very passionate about Arch, but I don't know if you all are very passionate about Arch or not. But anyways, let's do a follow-up scan, and we're going to save it into a file. So we're going to do nmap, and it's going to be the same command, but we're going to specify the ports. And we've got 6379, and we've got 8080. So 8080 is usually an HTTP proxy. Matt for Space says, looks like Tails OS looks like, look up Cubes OS. Cubes OS. Devil Dog says it has 2 distributions and runs on Tor, Unix. I wonder what the difference is between something like, I guess Unix isn't run completely in memory and doesn't delete everything after you're done with your session like Tails would do. I've never actually run Tails before, but I've heard a lot about it. Okay, so let's try running this nmap command. Let's supply the common scripts with this flag right here, and the versioning information with this one right here. And let's save that to, what is it called? This machine is called ready.txt. Ready nmap.txt. So I might come back to this after the class is done. Let's see. So Cubes OS is a privacy. Oh, it's a privacy OS Linux distribution. I'm assuming. Okay. Cubes is a VM. Tails doesn't let the main OS boot, so no records are made to the logs. So does it run completely in memory, or does it use the host storage? But either way, yeah, I've heard a lot about Tails Linux and how you can use it to remain anonymous. Actually, I think I heard about Tails Linux through Kevin Mitnick's book. I think it was called The Art of Invisibility. Yeah, this one right here. So I don't know if you all like to read books by hackers, but I did read The Art of Invisibility. I didn't actually read it. I listened to it as an audiobook, and it was pretty good. It pointed out the immense difficulty of trying to remain completely anonymous online, and it really pointed out to me that remaining completely anonymous online is a huge pain in the butt. But if you wanted to take a look at this, here's the link on Amazon. But yeah, I give this recommendation, because we want to pay tribute to the late Kevin Mitnick. If you don't know, Kevin Mitnick passed away. I think it's about a year. It's just over a year ago, and it's kind of sad that they had to go out. I think it was some sort of cancer that took him out. But okay, so to everybody here, if you're here for the HackerFrogs class for Python, please let us know in the chat that you're here for the Python for the Python class. It's going to be starting in a couple minutes. Matt from Space said, I heard his story but didn't know that he passed away. Oh, okay. Yeah, a lot of people are still surprised when they hear that he passed away. Let's look him up on Wikipedia really quick. Here we go. The most famous hacker in the world, Kevin Mitnick. Yeah, he was only 59, and I think he passed away from colon cancer. So over here, oh, pancreatic cancer. So yeah, he passed away in the summer of 2023. So it hasn't been very long. It's been about maybe 16 or 18 months. But sad to hear. If you want to read his books, he's got The Art of Deception and he's got The Art of Deception, The Art of Intrusion, and The Art of Invisibility. So this is the one that I've read. I haven't read his other two, but I probably should. So young, yeah. Well, I mean, you have to take care of yourself. I guess how can you pick up on pancreatic cancer early? Let me ask ChatGPT what are some early signs of pancreatic cancer. Pancreatic cancer doesn't often cause noticeable symptoms in its early stages, making it difficult to detect early. Huh. There are some subtle signs that may appear as the disease progresses. Being aware of these: abdominal pain or discomfort, unexplained weight loss, loss of appetite, jaundice, changes in stool, new onset diabetes. Screenings. Yeah, I guess going to get your health checkup is very important, especially as you get older. But fatigue and weakness, enlarged gallbladder or liver, blood clots. All right. Okay, so it's time to do our HackerFrogs Python class. So if you're new to Python, please stick around. Something tells me that the people here aren't necessarily new to Python, but yeah, I'm running this class for the next hour or so. After about an hour, we'll be finished with the class, and then we're going to go back and we're going to be going back to hacking, and we're going to be hacking against another Vulnix machine, which is this machine over here called Deploy. So that's going to be in about an hour. But in the meantime, we're going to do our HackerFrogs Linux class. So let's start. Let me just grab my presentation file for this. So this one is going to be for the programming course. This one is Python number 2. Okay, here we go. So this is HackerFrogs After School Python Programming Basics Part 2. This is a second session as part of an 8-part series teaching the basics of programming in Python. So in the previous section, we learned about the following Python concepts. We learned about the Hello World program. We wrote the Hello World program in Python, which is the first program students write for any computer language. We also learned about the print function. We learned how to use the Python print function, which prints information to the console and is common to almost all programs written in Python. Matt from Space says, I would stay, but I got to take my night meds and I'll be completely in 30 minutes. Check around soon. Good night. Well, to all of our people who, if you've got to go, you've got to go. But thank you very much for coming by, Matt from Space. I really appreciated your insight in chat, talking about Linux and stuff. But yeah, if you have some spare time and you see me online, maybe you can pop in again next time. But have a great night, and we'll see you in the next one. So we learned to use the Python print function, which prints information to the console and is common to almost all programs written in Python. We also learned about variables. We learned about programming variables named storage locations which hold specific values, which can be referenced multiple times in a program. And we learned about data types, which include strings, which are non-numeric text, integers, whole numbers, and floats, numbers which include decimal places. So basically, the big difference between integers and integers, floats, and strings in Python is whenever you see a string, it's usually going to be encased in single quotes or double quotes, just like this example over here. And if you see numbers in Python, they're not going to be encased in quotes. Otherwise, they would be considered strings. So that's what we need to know about these different data types. I'll be back next time. Okay, nice to see you, and have a great night. Matt from Space. Okay, so in this workshop, we're going to be covering the following topics. So the first part we're going to cover is about lists in Python, and in part two, we're going to be talking about arithmetic operations using Python. So part 1 is lists. So lists are part of what Python recognizes as collections. That is, variables that hold one or more values, which can be strings, numbers, or a mixture of different data types. So what does a list look like in Python? It looks kind of like this. So we've got our variable called vegetables, and we have a variable called related to pi, and these are both lists. So as we can see by the example, a list is defined as a number of objects separated by commas between a pair of square brackets. So we've got the square brackets over here. These square brackets in Python indicate that this is a list. And inside of the list, you can see different objects. We've got 3 strings in this case, 3 names of vegetables, and we also have this list over here called related to pi. We've got round and delicious, and we also have 3.14, which is the first 2 decimal digits of pi in the mathematical sense. Okay, so what we can do is we can create our own lists. What I like to do is I like to use a handy website called onlinepython.com, online-python.com. And you can access this yourself if you want to follow along. So the first thing you're going to notice is that there's already some code inside of this window when you load up this website. So what I would ask you to do is I want you to highlight all the code that is already here, and I want you to delete it. So just highlight it all and then hit the delete button or the space bar on your keyboard, and that's going to delete everything. What we're going to do next is we're going to create a list. So let's do, we're going to call this sample_list, and we're going to make this a list. So remember that a list in Python is going to be between a pair of square brackets. So just hit the square bracket key on your keyboard, and sample list is kind of boring. Let's make this about something exciting. What's super exciting? How about vegetables? Vegetables are super exciting. Let's make a list of 3 vegetables. So inside the list, we can provide some double quotes. So a pair of double quotes, and then a comma, and then a space, and then a pair of double quotes, and then a comma, then a space, and then a pair of double quotes. So from here, we can fill in our 3 vegetables between the double quotes here. So what's an exciting vegetable? How about a carrot? How about carrots? Carrots are exciting, and lettuce is exciting. And what is the most exciting vegetable? How about the potato? That's exciting. Okay. So we've got our list of 3 objects. So each one of these objects in the list is going to be separated by a comma. And remember, these don't necessarily have to all be strings. They can also be numbers, and they can also be other lists. If for some reason you wanted to create lists inside of other lists, then yeah, you can do that. But otherwise, we've got our 3 lists, our 3 objects in the list over here, and what we can do is we can print this out. So we would just use the print function and then the name of the list we want to print out. So we would just do print vegetables inside of these parentheses here. So if we run this, we're going to see that we've got carrots and lettuce and potato, and this actually looks exactly like the way it's formatted over here. Okay, so let's go back and learn more about these lists. So items in lists occupied ordered positions within it, called indexes, with the first item in the index 0 position, the second item in the index 1 position, etc. So what we can do is we can actually reference each object inside the list by doing what is called list indexing. For example, we've got fruits, and then we do the list indexing with the index 0. which is equal to the first item on the list. So this is an apple, and list indexing at the index number 1 would be orange inside the list, and index number 2 would be grapes inside the list. So let's give this a try. So over at Online Python, so let's try printing vegetables, but not the whole list. We're only going to print out a certain index. So what we can do is we can do, actually, you know what? This isn't, how about we make a new variable called first vegetable, and it's going to be equal to vegetables at index 0. So remember, because we're using man, this is these ads are distracting. Let me get rid of them. Okay, no more ads. Okay, so the first vegetable variable is going to be equal to vegetables at the index of 0, which is the first item. So we've got vegetables, and then inside the square brackets, 0. So remember, it's just the word, the name of the list, and then immediately after the name of the list, without a space, you do the square brackets, and inside the square brackets, you indicate which object or which index it is. So index 0 is carrots. If we print out the first vegetable variable over here, it's going to print out carrots. So let's run this. And it prints out carrots because vegetables index 0 is the word carrots. So we can also replace this, and let's say we don't want, well, let's just make a new one. We can call this one second vegetable. Vegetable. I should have used a word that's easier to spell than vegetables. Okay. So remember, because we're counting from 0, the second vegetable is at the number 1 index. So this is index 0 and this is index 1. So second vegetable should be lettuce. And if we want to print second vegetable, it's going to print out the object at index 2 of the vegetables list. Second underscore vegetable. Okay, and let's print this. Let's run this. Okay, now it says lettuce because lettuce is the second index. I keep on getting this confused. Anyways, it's index 0, index 1, which is the second thing, which is lettuce. Okay. All right, so let's go back. List indexing allows for a selection of specific items in a list by referring to them by the position in which they appear in the list. So, to use list indexing, we have to use the name of the list and then directly followed by a pair of square brackets with the index or position of the desired item inside the brackets. So we were just demonstrating that over at the Online Python website. So look at the Python code above. Inside the print function, the trees lists index 0 is referenced. Which list item will the print output? So print trees at index 0, is it going to print out cedar or elm or pine? If you think you know which one it's going to print out, please type it in the chat. Okay, so if you said that it's going to print out the pine, then you are correct, because index 0 is the first item in the list. So the output should be pine. Since pine is the first item in the list, note that counting positions in indexing starts from 0, not 1. In this example, trees 2 refers to cedar, since cedar is the number 2 item on the list if we count from 0. So trees 2, pine. Oh, hey, we've seen some new people here. Deshandes and Devil Dog says it is pine. And well, I guess you've got a bit of a lag on a delay on YouTube, but thank you very much for answering. Okay, but yeah, so cedar is the number 2 item. So 0, 1, 2. This is trees object index 0. Okay. All right. So next we're going to talk about changing index names. So an important thing to remember when working with lists is that the value of items in lists can be changed after initial assignment. So if we assign trees as a list, pine, elm, and cedar, and then we print trees 0, first of all, it's going to print out the object pine over here, and then we change the trees at index 0 and replace pine with oak. Then the next time we print out trees at the 0 index, it's going to print out oak. So let's demonstrate this. So over at onlinepython.com, and remember, if you want to follow along, you can use this link over here. But before you can use the website, you have to delete the code that's already there. So we're going to leave the page. So when you load up the page for the first time, it's going to have this code over here. Just highlight it and delete it, and then you can start coding. So let's create that list, trees. So trees is going to be a list. 3 things on the list. Let's make it oak, and let's make an elm, and let's make it maple. So these are all trees, but let's change the 3rd item. So this is index 0, this is index 1, and this is index 2. So if we want to change index 2 from maple to something else, we would do maples2 equals, and then a new thing. So the new thing here is going to be, let's make this spruce. Okay, and then let's print out the entire trees list. So print trees. Okay, so trees is a list, and then we change the index 2 item in trees to spruce. So maple is replaced by spruce, and then we print the entire trees list. So let's do this. So it should come out as oak and elm and spruce. Okay, so let's move on. So we've got data types and classes and objects. So every data type in Python, lists and strings and integers, belong to a corresponding class, and each instance of a class is an object. So there are different, basically we were talking about data types last time, but in Python, data types belong to their respective classes. So strings are considered a class, and integers are considered a class, and lists are considered a class. So for example, if we have this empty list over here, and then we use the type function to get the data type for the empty list, it's going to say that this is a list. So we know that lists in Python are their own class. So next we're going to talk about methods. So what are methods? Methods are class-specific functions. So remember when we said that that each object in Python belongs to a specific class? So for example, we've got these this list class of object, and we've got our string class, and we've got our integer class, etc. So methods are class-specific functions. So basically, they're little operations that can be run on objects of a specific class. For example, there are list methods, there are string methods, there are integer methods, and etc. And methods perform actions on the object. So methods are little actions or little instructions that can be performed on these objects of a specific class. So what does this mean? This means that we can run these methods on these different objects and get some different results. For example, we've got our vegetables list. So the vegetables are carrots, lettuce, and beets. It's a list of 3 objects. But we can also run this list method here called append. So append is a list specific method, and what it does is that it adds an object to the list. So the append method, we can run this and we can supply the string radishes, and then when we print the vegetable list next, we see that radishes is added to the list. So let's demonstrate this. Actually, before we demonstrate this, let's find out how to run this method. So methods are performed by indicating the name of the object. In this case, it's the list, then a dot, and then the name of the method, followed by a pair of parentheses, which contain any arguments required for that method. So the name of the list here is vegetables, and then we supply a dot, and then the name of the method, which is append, and then a pair of parentheses. Anything we need to supply to the method, we're going to put inside the parentheses. So this is going to add the radishes object to the list. So it's easier to demonstrate this. So we've got our trees, and let's just say we wanted to add something to trees. So it would be trees and then dot and then append, because that's the name of the of this particular method, and we want to append something. So inside of the parentheses, we're going to supply the name of the thing that we're going to append to the list, and that's going to be another tree. So let's call this one pine. So trees.append and then pine. This is going to add the pine object to the end of the list. So when we print the trees list out, it's going to be oak and elm and maple and pine. So let's try running this. We got oak and elm and maple and pine. So everybody, I want you to try using the append method over here. So try creating this list over here. If you're having some trouble, let us know and we'll try to help you out. So on the first line, create your trees list with oak and elm and maple. Remember that each one of these objects needs to be separated by a comma, and each one of these strings has to be inside of these double quotes or single quotes. So on the second line, I want you to add a tree. So it would be trees.append, and then inside of these parentheses, put in the name of the new object. In this case, it might be pine. It could be something else. It doesn't need to be pine. And then the next command is going to be print inside the parentheses trees. So if you're able to get 4 items in your print over here, please type in the chat, I added a tree. Smiley face. So I'll give everybody about a minute to try to complete this. In the meantime, I'm going to take a little sip of water. Just a second. Okay, everybody, did you manage to add that tree? So one more time. So it's going to be trees equal to, inside of the square brackets, these three objects here. Separate the objects with our commas. Then trees dot append, and then inside of the parentheses, supply the name of the object you want to add. Then print the trees, and you should have 4 objects here. Okay, so let's move on. So the list method we will learn in this workshop is the append method. The append method will add an item to the end of the specified list. So take the following code as an example. We've got our friends, they're equal to Alex and Barb, and we want to add a new friend to the list, which is Carl. So it would be friends.append Carl. And then when we print our friends list, we'll see that the output should be Alex and Barb and Carl. So this is, I guess this is a little more this is a little more exciting than printing out a list of trees, but thank you very much to the people who participated anyways. All right, so we've got our append method, and then we have the del keyword for deleting items from lists. So say that for some sad reason we wanted to delete one of our friends from our list of friends. Deleting items from lists can be done in a few different ways, but if you know the list index of the item you want to delete, you can use the del keyword. So we've got our friends, Alex, Barb, and Carl. If we wanted to delete the friend, the object at the friend's index 0, which is Alex, we would use del and then space, and then friends index 0 with this syntax right here. And then when we print our friends, we see that Barb and Carl are still here, but Alex is missing. So to delete an item, use the del keyword, and then the name of the list, a pair of square brackets, and then index of the item to be deleted inside the brackets. So lists exercise. Let's cover the next few exercises on the learnpython.org website. So I don't know if we necessarily need to. Okay, well, let's go to the learnpython.org website. Okay, and I think what we need to do is we need to go to the lists page. All right, so if you want to take a look at this web page that we're looking at here, you can go to this link. Let's make this nice and big, so we don't have to see all the ads on the end. So okay, so what are we talking about? What does this page want to tell us about lists? So lists are very similar to arrays. The interesting thing here is that they don't actually tell you very much about arrays before they start talking about this, but they can contain any type of variable, and they contain as many variables as you wish. Lists can also be iterated over in a very simple manner. Here's an example of how to build a list. So it actually shows us that we don't need to create lists with things in them. So we can actually make empty lists. And the first line of code in here, it shows that we're creating the my list here as an empty list. So you just provide the square brackets without anything in it. And then what they do is that they start adding things to the list in the next few lines. So for example, in line 2, my list, they're going to add an object, which is the number 1. So remember, whatever we want to be added to the list, we have to include inside of the parentheses here. So this is going to add the number 1, and then the next line is going to add the number 2, and the next line is going to add the number 3. And here, they're printing out the items in the list by their index. For example, index 0, index 1, and index 2. So everybody, if I'm going too fast, or if there are any if you have any questions about any of the terms that I'm using during this class, please let us know in the chat that if you are confused or if you have questions, because I certainly don't want anybody to get lost in this class. Okay, so we've got our print function, our print commands on lines 5 through 7. So print the first item, print the second item, and print the third item. So they also have this this for loop over here, which is also going to print out items. We're going to be talking about for loops later on in the course, so you don't really need to pay too much attention to the code over here. Just know that this for loop is going to print out each item in the list. So what this should output over here is the numbers 1, 2, 3, and then the numbers 1, 2, 3 again. So if we run this code, it's 1, 2, 3, 1, 2, 3. Okay. So next, accessing an index which does not exist generates an exception, otherwise known as an error. So we've got our list over here, and we've got our my list, and it has 3 items, the numbers 1, 2, and 3. If we try to print my list at index 10, and index 10 is the 11th item, we're going to see that there's an error over here. It says list index out of range, because this list doesn't have an 11th item. So that's what this section is trying to talk about. Okay, so inside the exercise, it says you will need to add the numbers and strings to the correct lists using the append list method. You must add the numbers 1, 2, 3 to the numbers list and the words hello and world to the strings variable. Okay, so everybody, let's try to solve this exercise here. So what we need to do Oh, okay, there's a third. Sorry, I didn't see this third instruction over here. I'm sorry. Okay, so what we need to do to finish this exercise is you need to add the numbers 1, 2, 3 to the numbers list. You need to add the words hello and world to the strings variable. And then you have to fill in the variable second name with the second name in the names list using the bracket operator. Okay. So everybody, let's demonstrate over here, okay? So we've got numbers. This is an empty list. And we've got strings. This is an empty string. And we've got names. We've got John, Eric, and Jessica. So what we need to do is we need to write our code here. So on line 5, we're just going to add an extra line over here. So on line 6 over here, we're going to do numbers.append. And this is a method, of course, which means we need to include our parentheses. And we need to add the numbers 1, 2, and 3. So to add the number 1, this is what we would do. Numbers.append, and in the parentheses, we include the number 1. We have to do this 2 more times. So we're just going to copy this, this code over here. And in each one of these, we're going to give a different number. So append 1, append 2, append 3. Next, we need to do something to the strings list. So it'd be strings.append. And inside here, we have to add the words hello and world. So we add the words hello. And we create another one. We're going to copy this line. But this time we're going to put in world. So it's hello, strings.append, hello, strings.append, world. And we have to define the second name variable here. So the second name variable has to be the second object in the names list. So the second object in the names list is Eric. So is this index 1 or is this index 2 or index 1? If you answered index 1, you're correct. So because we start the indexing from 0, this is 0. This is 1. This is 2. But the second name is Eric, which is index 1. So we're going to define second name as names, square bracket, 1. Okay? And that's going to let you complete the exercise. So click on submit, and then it should tell you that you did a great job. So if you're having a bit of trouble following along with what we're doing here, let us know in chat, and I'll try to explain. I'll take a second to explain as best I can. Okay. All right. So let's move on to the next part. So the next part is our quiz. Okay. So everybody, let's take a little bit of time. Deshandes asks, could you not have put all the numbers in one number.append? The number.append 1, 2, 3. Oh, you know what? We could have. I'm pretty sure we could have. Let's go back. Okay. So let's adjust the code over here. So append 1, 2, 3 like this. So I think we can, okay. So if this works, that means that this also works. So we can do hello and world in the same line. Yeah, well, I mean, I didn't, so you can do it one object at a time. I'm pretty sure you can also do it all at once, but let's try submitting this. Ah, okay. So this actually doesn't work because append takes one argument. All right. So append doesn't work if you supply multiple objects to it at once. So it just wants. Okay. So we answered that question. I guess we can't use append with multiple objects at once. But you know what we could do? We could do. That was a very interesting. That was a very interesting example you brought up there, Deshandes. Thank you very much for bringing that up, because I actually hadn't tried assigning multiple objects at the same time using append. But let's do the quiz. Okay, so the quiz is, which of the following statements about Python lists is true? So you got A, B, C, and D. When printing a list, all items in the list must be printed. A, is this true? B, it's not possible to add items to a list after creation. C, counting items in the list starts from 0, not 1. And D, items in the list cannot be changed after they've been added. So which one of these is true? A, B, C, or D? If you answered C, you are correct. So counting items in a list starts from 0, not 1. So this is something that, that we have to get used to. And this is the only thing that is true about Python lists in this list. All right, so we've got one more question. So Devil Dog and Deshandes answered C. You are correct. Okay, so the next question is, which of the following code will add a string item, apple, to a list named fruits? So we've got the list named fruits, but we want to add the apple string to the list. Which one of these little code snippets is going to do the job? Is it A, B, C, or D? If you answered B, then you are correct. So it's going to be fruits.append, and then inside of the parentheses, it's going to be the name of the object. So for example, apple, or you could do a number or something else. All right, so the answer is B, Devil Dog and Deschandes. Thank you very much. You're correct. Okay, so the next thing we're going to move on to is basic operators. So when we're talking about operators, what we're talking about is some arithmetic operators. In programming terms, operators are used to perform an operation on a piece of data. We call them operators because they operate on the data. So in this lesson, we will learn about basic arithmetic operators that are used for mathematical addition, subtraction, division, multiplication, and a couple of others. So this is what we use computers for. We use computers to do math for us. So Python uses the following operators or symbols for basic arithmetic. So some of these are similar to the ones you learn in your basic math lessons, but some of them look a bit strange. So for example, we've got our addition and it's our subtraction, which look like anything else, but for multiplication we use a star. So if we do x times y, this is the example right here, x star y. And if we want to do division, we have to use this slash. So x divided by y looks like this. And if we want to do exponentiation, which is basically something to the second power or something to the third power, we would use this symbol. So x to the y power is created like this. X star star y. I need to take another little drink of water. Just a second. Okay. Yeah, something's wrong with my voice today. Okay, so the arithmetic operations that occur in Python follow the PEMDAS order of operations. So in your math class, you might have learned different methods of what order the operations go in when you do mathematics. But I learned it as PEMDAS, which is everything in the parentheses, then we do the exponents, then the multiplication, the division, the addition, and the subtraction, which spells out the word PEMDAS. But just keep in mind that all the math that is done in Python is done in a very specific order. So in summary, all operations enclosed in the parentheses are performed first, then all exponent operations, followed by multiplication, division, addition, and then subtraction operations at the end. So given the following equation in Python syntax, we've got 4 divided by 2 times 2 to the second power, so 2 squared, divided by 4 plus 2 minus 4. So we're actually going to solve this equation inside of Python in just a little bit. But let's talk about in what order these operations are done. So first, the division operations inside of the parentheses are performed. And then second, the exponent operation is resolved. And then third, the multiplication is resolved. Devil Dog says, please excuse my dear Aunt Sally. Well, whatever way you want to remember this is fine. I just remember it as a word, PEMDAS. So I don't remember it as like, please excuse my dear Aunt Sally, but everybody learns, depending on where you are in the country, you might learn it in a different way. So fourth, the division is done, and then fifth, the addition is done, and finally, the subtraction is resolved, which sets our final result to 0. So if you don't, if you want to test this out yourself, I'm going to provide this equation in the chat for everybody to try out. You can copy that, and then you can go over to the online Python website, and we can create this equation. So let's just call this math underscore example, and we're going to call it equal to this. So let's see, in the example here, we say that it sets our final result to 0. So this entire thing over here should equal 0. So if we go over to here, after we set up our variable, we're going to print the math example, math underscore example. So when we try printing that, it's going to print out, it's going to output 0.0. So it's 0.0 because we did division, and when you do division, everything that comes after the division is going to come out as a float. So that's why that happens. But yeah, you can do all sorts of math inside of Python. For example, let's say that we don't want our math example anymore. We could do anything. We could do any math we wanted to. So maybe we do 8 plus 92 divided by 7 times 4. Anything like this. And then we can just print this out, and it's going to give us the result. Hopefully this is true. Hopefully this is accurate. But yeah, this is why we have computers, to do math for us, because we don't like doing math, or at least I don't. But you may be a different person. Okay. The next thing we're going to talk about is the modulo operator. So the modulo operator comes up all the time when we do programming, and a common operator used in programming is the modulo operator that looks like the percent symbol over here. We've got our 5 modulo 2, which equals 1, and we've got our 8 modulo 5, which equals 3. So what does this mean? It looks a little bit strange. A modulo operation returns the remainder after one number is divided by another. The resulting number after a modulo operation is called the modulus. So the result of these operations are called the modulus. In this case, number 1 is the modulus and number 3 is the modulus. So if we divide 5 by 2, the remainder is the number 1. So 2 divides into 5 2 times, which equals 4. When we subtract 4 from 5, we get 1, and this is the modulus. We've got 8 divided by 5. If we divide 8 by 5, we get 1, which is 5. And then when we subtract 5 from 8, then the remainder is 3. So the modulus in this case is 3. So a typical use for the modulo operation is to determine whether a number is even or odd by performing a modulo operation on it with the number 2. If the result is 1, then the number is odd, and if the number is 0, if the result is 0, then the number is even. So let's try this out. So over at Online Python, we've got a number, and the number is equal to 81. What we want to do is we want to do number modulo 2, and we're going to print that. print number modulo 2, and this should come back as 1 because this is an odd number. So let's try running this. So this comes back as 1. So if we change the number from 81 to 80, then when we print number modulo 2, it should come back as 0. So let's run this again. It comes back as 0 because this is an even number over here. Okay? Actually, no, you know what we could do? We could write a little program. So we could do number is equal to input. And the input is going to ask us a question. Input a number. And then we're going to Actually, this requires us to okay, we're gonna write a slightly simpler version of this. So let's do the result of the modulus operation is, actually wait, we have to put this between quotes. Let's put this between, just like this. Okay, so the result of the modulus operation is number modulus 2, and it's going to ask us for a number. So we can run this program. It's going to ask us for input, and we're going to input a number, and then it's going to tell us whether or not the result of the modulus operation is 0 or 1. Actually, let's do the result of the modulus operation by the number 2. Okay, so let's try running this. Run it, and then it asks input a number. We're going to input the number 2. Oh, okay. Not all arguments converted during string formatting. Oh, this is because this is a string. Oh, okay. We need to change this. So input by default is not going to save a number. It's going to save a string, and we can't do mathematical operations on strings. So what we need to do is we need to indicate that this is an integer. So we need to convert everything in the input to an integer by putting this part at the front. So int parentheses and then a parentheses at the end. This is going to save the number as an integer. So just know that there are all sorts of weird quirks like this in Python. So let's run this again. Input a number. Let's do 2. Can you only concatenate strings, not ints to string? Okay, hold on. Okay, let's get rid of the plus sign there. And then we can try this again. Sorry, strange rules. Okay. Anyways, let's move on. Sorry about that. I hadn't completely thought out this section. Well, I didn't that weird example before. I just kind of did that off the cuff. All right, so we're running out of time. So what we're going to do is we're going to skip over to the quiz. So we've got our basic operators. Which of the following methods will allow us to print a string and an integer with the same print function? So this is actually we didn't talk much about this, but the answer here is that if we want to print integers and strings in the same print function, the integer has to be converted to a string first in order to mix it in a print function. So because we were kind of rushing through this, we didn't cover this. But question number 2, which of the following math equations will let us determine if a number is even or odd? So we should know the answer to this question. So there are these operations right here. Which one is going to let us know if a number is even or odd? We've got A, n plus 2, B, n star star 2, C, n percentage sign 2, and D, n minus 2. All right, so the answer is C. Deshandes, thank you very much. This is what we would do. We would use the modulus operation to determine whether or not a number is even or odd. Okay, so we've got an extra little thing. This is the character function, the CHR function. In Python, the CHR function is used to convert numbers to their Unicode equivalents. So when we're talking about Unicode, we're basically talking about a system that turns numbers into letters and other symbols. So Unicode encoding is what lets computers turn bytes into letters and numbers for the monitors and other screens. For example, if we run character 65, this function inside of Python, the result will be the uppercase letter A. So the reason why character 65 is the letter A is because it's using Unicode. And if we look up Unicode on the internet over here, Unicode chart. Let's see. Okay, this isn't what we're looking for. We're looking for something like... Actually, let's just look for ASCII. Okay, so over here, actually, if you want to see the same table that I'm looking at, we're looking at this table right here, and we're talking about ASCII in this case. So 65. So we've got a number over here in decimal, 65, and an associated character, which is the letter A, and all of these different numbers here are going to convert over to different characters inside of this encoding scheme over here. So for example, we've got all of our uppercase letters, our numbers and symbols over here, and we're going to use this to solve a little challenge inside of picoctf. And what we're going to do is we're going to use Python to solve the challenge. So if you still have your picoctf, please log into the website, and then we're going to go over time by a couple of minutes. I hope that's okay for everybody. So please log into the picoctf website. And after that, I want you to open up your web shell. So once you're logged into the picoctf website, click on Practice and scroll down a little bit, and then click on the web shell button over here. So the web shell is going to give you a little Linux terminal to work inside of, and we can actually use Python inside of the Linux terminal here. But in another tab, let's see. I'm going to pull up a challenge. So we're going to do a challenge from picoctf. And this one is going to be Python session 2. And we're going to do the glitch cat challenge over here. So after you've logged in, please go to this link. And this is going to bring you to the glitch cat challenge. So it says, our flag printing service has started glitching. So additional details will be available after launching your challenge instance. And then there's a button over here, a blue one, which is called Launch Instance. So go ahead and click on that. And after a few seconds, it's going to start up the challenge server associated with this challenge. Sometimes it's going to error out. It's going to say the server did not respond. You just need to click on the button again, and hopefully it goes through. Maybe you have to click on it a third time. Okay, this time it starts. Great. Okay, so after the instance starts, you're going to see a timer over here that's going to count down, and you're also going to see a netcat command over here that is going to let us communicate with the server. So what I want you to do is I want you to highlight the netcat command from the start of the end until the end of the last number over here. So right click and copy it. Then you can go over to your web shell. And the web shell you can actually make nice and big by clicking on this button right here called Pop Out Web Shell Terminal. So after you've done that, you can paste in your netcat command over here, and then hit enter. And then it's going to give you, this is going to give you a flag, but this flag is not complete, but it does have all of these Python CHR functions. So the CHR functions are going to be printing out different characters. But because we know that this is a Python function, we can actually execute this in a Python environment. So we can copy all of this output over here, and then we can actually bring it over to our online Python over here. So we're going to make a variable in online Python. We're going to create a variable called flag, and then we're going to set it to whatever we paste in over here. So this is all code, and this is all one string. So what we're going to do on line 2 is we're going to print the flag. Okay, so we've got our flag. It's equal to this code right here, these characters plus these functions, and this is all Python compatible. So after we write this code, we can run this code, and it actually gives us the whole flag, because these functions over here are interpreted as different ASCII characters when the flag is printed. So to complete the challenge, all we need to do is click on Copy to Clipboard, and then go back to our challenge page. So at the challenge page, glitchcat, we can scroll down, and in the flag submission field, we can paste in the flag. Unfortunately, it gives us more output than we need. All we need to do is delete all the other output that's not the flag. So we've got the flag over here, then all this other output. We can just delete everything else. And then we can click on Submit Flag to finish the challenge. Okay. All right. So we just used a little bit of Python to complete this challenge over here. But before we finish the class, let's do a little review of what we learned in today's class. So what we learned in today's class is we learned about lists. We learned about lists, which are variables with one or more items associated with them. Items in the list can be referenced by a process called list indexing. And the other thing we learned was about basic operators. So basic operators are used to perform arithmetic operations. So what we're going to do in the next class is we're going to be learning more Python, of course, and we're going to be solving some PicoCTF challenges as well, but we're going to be learning a few new things, such as string formatting. And remember, strings are pieces, little bits of text. We're going to be learning about how we can format our text by using string methods, which are little operations we can run on strings, as well as string splicing, which is basically taking certain chunks of the string and outputting strings in different ways. So that's going to be the next workshop, and that's going to be on Friday. So please look forward to that. And we're going to be here on Friday at the same time. Until then, have fun, and we'll see you next time. As usual, if you have any questions about anything that we learned in today's workshop, please let us know in the chat. Because I'm here to teach everybody, and if there's something you didn't understand, or if there's any other questions about Python that you have, please let me know, because I don't want anybody to be left behind. And I'm here to teach. Anyways, but yeah, that's going to conclude the HackerFrogs session for today. Well, like I said, we're going to be back on Friday. But we're going to do the last portion of today's stream, and the last portion is a little bit of hacking. So if you haven't done any network hacking before, then this might be something new to you. What we're going to be doing is we're going to be hacking against a certain machine that we downloaded from this website over here called vulnix.com. So if you want to take a look at the virtual machines over here, then you can see them at this particular website here. And if you want to know about setting up your own virtual machines on a network, we actually did a little bit of a workshop on that on Monday. So you can actually find it. Oh, this is some streamception over here. Let me find the correct VOD. So over here, let me grab that link. If you go over to this YouTube video of the live stream from Monday, so the first 30 minutes of this live stream are dedicated to talking about how to put virtual machines on a network. So if you were wondering how to do that, you could do so. You could find out at that video. All right. So the first thing we want to do to solve this challenge over here is we want to start up our virtual machine. So this challenge is called deploy. I've already added it to my network, and I'm going to start up the machine now. Okay, so we can see that this machine is over at 10.0.2.30. So we're going to start scanning at that IP address. So the first thing we do when we investigate a CTF challenge like this is we run an Nmap scan on it. So Nmap is going to scan all the open ports on a particular server and tell us which ports are open on the machine. So what I like to do is I like to run nmap with the following flags, arguments. So we've got -vv for very verbose output. So that means that as soon as we get output, it's going to report back to me. The next thing we like to do is we like to run nmap against all ports, which is indicated by this right here, -p-. And the last thing we need to supply to nmap is the number of threads we want to run at the same time. So the more threads that we run at the same time, the faster the scan is going to go. And so we've got T4, which is 4 threads. And that's going to run relatively quickly, but it's not going to be too quick as to miss out on details. So, and then we have to supply the IP address where the server is at, which is 10.0.2.30 in this case. So when we run the scan, we're going to receive the following ports that are open. So we got port 22, port 80, and port 8080. So port 22 runs SSH, port 80 runs HTTP, and port 8080 usually runs an HTTP proxy service. So the next thing we want to do is we want to get more information on these ports. So we're going to run the same command as we did last time, but we're also going to specify which ports we're scanning, which in this case are 22 and 80 and 8080. And we're going to add a couple of more arguments, such as this one, -S_C, which runs common scripts on these services. So if there's some sort of common exploits that we could, or vulnerabilities we could find on these services, it'll run a script to see if it's vulnerable to any of them. And we're going to run it with -S_V, which is going to return versioning information for any services that we find. So when we run this, we're going to see that port 22 is running the SSH service, and it's running OpenSSH version 8.4, which is a pretty recent version of OpenSSH, which means that it shouldn't be vulnerable to any known exploits. Next, we see port 80, which is running an Apache web server with version 2.4.56, and it reports Debian, which is the what is it called? The distribution of Linux that the web server is running. And we see that the HTTP title here is Debian default page. It works. So this actually is not. This is not a great sign for us as security testers, because it doesn't mean that it means that there's probably not an actual web page up on port 80. But we also get this message over here, which is port 8080, and it's reporting that there's an Apache Tomcat server running on this port. So Apache Tomcat is another type of web server, and the Tomcat web server works with Java. I think it works with the Java framework, but I could be wrong. I think that's what it is. You know, if we wanted to be sure, we could probably ask ChatGPT about what Apache Tomcat is. So what is Apache Tomcat? Okay, so it's an open source web server and servlet container developed by the Apache Software Foundation. It's designed to serve Java-based web applications and provide an environment where Java servlets and the Java server pages, JSP, can run. Okay, so it's a type of web server that is based in the Java language. So the next thing we can do, now that we know that port 80 and 8080 are running HTTP, is that we can do a little bit of web server enumeration. And what I like to do is I like to run the Nikto web app application vulnerability scanner. Oops. And so Nikto as a web app vulnerability scanner it's going to try to get determine if the web app is vulnerable to some common security misconfigurations. Nikto is not a super sophisticated tool, but it can return some interesting results. So and the it's also installed on Kali Linux by default. So that's why I like to run it. So what do we have here? So at the very least, it can give us some information, some additional information about the web server, like the server version over here, and the HTTP methods allowed on the server, but not very much else. So that was run on port 80. We also want to run this on port 8080 as well, because port 8080 was also running a web server. So we're going to run the same thing, but this time we're going to specify port 8080 over here. Okay, let's do this. Okay, so this says appears to be a default Apache Tomcat install. So depending on the version of Apache Tomcat, there might be some vulnerabilities associated with it. Oh, it says here at Manager, default account found for Tomcat Manager application, ID Tomcat and password secret. So we managed to find some extremely big on Twitch says, could you run this similar to GoBuster? Could I run this similar to Go? I could run GoBuster and do some directory enumeration on this web application. That is possible, but I've got a few different tools that I would like to run for web applications. So I like to run my Nikto scan first, then I run my derb scan second, and I run my GoBuster or other directory busting tools third. But yeah, I do run GoBuster pretty regularly when I have web applications to test against. So we found these default creds, Tomcat and secret. So we could actually explore this right now. So Tomcat secret. Let's access this on our web browser. So this is the address, and we're going to go over to the web browser, and in here, I need to go back and do that again. Extremely Big says, gotcha. I haven't used Nikto much. Nikto, people like to say that Nikto is old and that you shouldn't use it, but you can actually find all sorts of interesting vulnerabilities. Like this one over here, it checks for default accounts if it encounters an Apache Tomcat installation over here. So it actually picks up on a lot of different stuff. So I like using it. All right, so copy selection. Let's go over to that web page. Okay. So here, this is the default Tomcat installation. So it says that there's a manager app and there's a link. So let's go over here. It's going to ask us to sign in. It's using basic auth. This is not a secure method of logging into a website, but I think the username is Tomcat and the password is secret with a 3 instead of a first C. And we're able to sign in. So if I remember right, I can use Tomcat. I can use this app in order to upload a malicious file and get access to the server by activating the malicious file. So I don't remember how to do this, so I'm probably going to ask Hacktricks to help me out. So over at Hacktricks, I'm going to ask about Tomcat. So there should be an article about how to do a reverse shell with Tomcat. So Tomcat bind and reverse shell with Tomcat war deployer.py. So there's this reverse shell. Let's click on here. Okay. So I think so maybe I'm getting ahead of myself. So first of all, what do we know about this web application over here? So at this manager endpoint over here, we can upload files. So we can deploy. Sorry, let's make this interface bigger. Okay. So what we can do with this application is that we can upload files to the application, and we can also deploy or run these files. And we need to use a particular file format, which is called the WAR format. And I think we need to write the file first, and then we need to write the file to be uploaded, and then upload the file, and then deploy the file, and then that's how we would get a reverse shell on the system. So, you know what? I'm gonna cheat. I'm just gonna ask ChatGPT and have it walk me through the process. Over here, okay. So we are solving a CTF challenge. The CTF server is running an Apache Tomcat web server, and we have access to the manager page because the app is using default credentials. How can we write a malicious war file to upload to the app and gain shell access to the web server? Okay, what is it going to say? To gain shell access by uploading a malicious war file via the Apache Tomcat Manager page, you can follow these steps. Step 1. Create a malicious war file. Web application archive. File is a packaged web application that Tomcat can deploy. You can generate a war file by containing a reverse shell payload to get a remote shell. So for example, you can use MSF Venom to create the war file. You can use the MSF Venom tool from the Metasploit framework to generate a war file with a reverse shell. Run the command on your attacking machine, the one you control. Okay. So Java. So okay. So MSF Venom is a framework we can use to create malicious binaries. So when we use MSF Venom, we have to supply a bunch of different parameters, and then what it's going to do is it's going to create a malicious file that fits the parameters that we feed to it. In this case, we're providing the following arguments. So the payload is going to be Java JSP shell reverse TCP, and this is the type of reverse shell that is going to be used in the payload, which is a JSP reverse shell. Second, we have to supply an L host, which is our attacking machine IP. So the address of your attacking machine, the L port is the listening port we're going to be listening on the attacking machine to catch the reverse shell. We have to supply -F -f war to format the output as a war file, and the output is going to be war shell.war is the output name for the malicious war file. Second, we need to upload the file to the web application, and then we have to deploy the war file. Okay, so first of all, what we're going to do is we're going to create the malicious file using the MSFvenom utility. So we're just going to copy this code, and then we're going to go over to our Kali Linux. Okay, and we're going to modify this NSFvenom command over here. So what we need to do is we need to supply our IP address. In our case, it's 10.02.22. And listening port, we're going to put our netcat listener on port 443, which is a port that is often not blocked by web servers because 443 is associated with HTTPS. So the next thing we're going to do is we're going to output the file. And after NSFvenom is finished, it's going to tell us that it's saved as shell.war. And we see that shell.war is in our directory now. So let's go over to another tab, and what we're going to do here is we're going to set up our netcat listener on port 443. So we need a listener to catch the reverse shell, so we're just going to use netcat for this. So we're going to listen on this port, and hopefully we're going to get the web application to send out a reverse shell connection to our attacker machine over here. So we've got our malicious war file over here. So the next thing we need to do is we need to upload this to the application and then deploy it. So over here, we need to upload the war file. Okay, so go to the Tomcat Manager page and then find the war file to deploy section, upload your malicious shell.war file. So let's go over to the manager page. Let's see. So we're going to war file to deploy this section here. We're going to browse. This page is really bright. And then we're going to select our malicious file in the temp directory. Here we go. So shell.war, this is the malicious file. Select it, open it, and then I think we just need to click on the deploy button. Okay. All right, so the next step is to do what? Upload your malicious shell.war file. Okay. Tomcat will deploy the war file and make it accessible under the name of the war file, for example, at /shell. Step 3, set up the netcat listener. We just did this. Step 4, trigger the payload. Once the war file is uploaded, trigger the reverse shell by navigating to the deployed web shell. The URL will look something like this. Okay, so over at the manager, we see that so it's located at the /shell directory. So I think what we need to do is we need to go over to the address bar. Everything after the 8080 and the slash and the address bar, we can delete that, and we can replace this with shell. So it's going to be IP address. We need to prepend this with HTTP. So pretend with HTTP :// the IP address :8080 and /shell. So when we navigate to this page, we're going to see that it's blank, but if the code in the malicious.war file went off, we should have a connection from our reverse shell. So we can go back to our reverse shell here, and we see that we've gotten a connection. So we're in. So this is a great opportunity to put on my voice changer and put on my my deep hacker voice. Is if My voice. Okay, so if you think I have a deep voice, some people do and some people don't, then the voice changer is going to give me an extremely deep voice. So because we just got our connection on the machine, our foothold.
I'm going to put on my deep hacker voice, and I'm going to put on my Hollywood hacker imitation. I'm going to say, "We're in."
How is that? Was that a deep voice? Okay. So from here, let's ask who am I? We are Tomcat. So we're the Tomcat user on the system. And let's see if the Tomcat user has any special sudo permissions. So we actually can't see whether or not. Okay, so what we need to do first is we need to upgrade our shell. So the netcat shell is not very stable and not very functional by default. So what we can do is we can use Python in order to upgrade our shell slightly by using the following Python command. It's going to be Python 3, and so it might be Python or it might be Python 3, depending on what's available on the system. We've got Python 3, so we're going to give the following command. So the command is going to be pty, it's going to be import pty, import the sudo terminal module, and then it's going to be pty.spawn for this method, and it's going to be, we're going to spawn a bin bash terminal. So this is going to slightly upgrade our netcat shell. So we see we actually get a prompt now. We're now Tomcat at deploy. So deploy is the name of the host, I think. So if we do host name, yeah. So host name is deploy, and we are the Tomcat user, and this is what the prompt is over here. So from here, we can actually do sudo l, and this is Spanish. The user ID is not 0. What? I can't read this. Let's translate this in Google Translate. Okay, translate.google.com, and let's auto detect and translate it to English. The user ID is not 0, is on file system with the no SUID option set. Okay, so what does this mean? Does this mean user bin sudo doesn't exist? Let's check. So sudo does exist. This is an unusual message. This is an unusual message for sudo-l. I've never seen this message before. Not too sure what this might indicate. You know what? We can ask ChatGPT what this might indicate. We ran sudo-l on a Linux server and got the following message. What does it indicate? Paste in. Okay, so it suggests that there is a problem with the sudo command related to SUID bit or the file system settings. UID is not 0. The user ID of the user running the command is not 0. UID 0 is reserved for root. In this case, you're running sudo as a non-root user. Sudo on a file system with the no suid option. The suid bit is a special permission that allows executable file to run with privileges of the file owner, often root. Sudo binary relies on the suid bit to allow users to elevate privileges. If the sudo binary on the file system has been mounted with the no suid option, it prevents files with the suid bit from being executed with elevated privileges. As a result, sudo cannot function properly because it can't escalate to root privileges. NSF file system without root privileges. If the file system is a network file system NSF mount and the NSFS is configured without root privileges, sudo may not work correctly because the sudo privileges are not passed over the network. So does this mean that we're in a NFS file system? So check the mount options. Run mount or cat proc mounts to see if the file system where user bin sudo resides has been mounted with the no suid option. Jug Pearl, hello, nice to see you again. How are you? Let's celebrate Jug Pearl's arrival with a fun little hack the planet.
Hack the planet! Hack the planet! Shut up and get in.
All right, yeah. So we're just hacking against this this challenge over here called deploy from Volnix over here. So if you want to take a look,
Hack the planet!
that repeats.
Hack the planet! Shut up and get in.
Anyways, so it's from this website over here. If you wanted to try it out yourself, it's the deploy challenge. It's number 22 on the list. We just got our Kid Boo says, "Hey, what about me? We can give you a redeem as well. Let's give you this one."
This one's dedicated to all the hackers. Yo.
Welcome, Kid Boo. All right. What were we doing? Okay. We were checking about whether or not this system has a NFS mount. If the file system is a NFS mount, check the NFS server settings to see if root privileges are restricted. Okay, so over here we've got our file system. Let's which mount? So there is a mount directory. There's a mount program, and we can go over to the mount directory. There's no such file or directory. Oh, it's not the mount directory, it's the MNT directory. So cd MNT. So there's nothing in the mount directory, okay? So would you like checking the mount options or understanding how to modify them? So run mount or cat proc mounts to see if the file system where this pseudo binary resides has been mounted with the no suid option. Cat proc mounts. Okay, we can try that. Cat proc mounts. I actually don't know how to interpret this information over here. I guess SDA1, these are the different disks. So dev SDA1, so these are different disks over here. I don't know. Let's feed this to ChatGPT. Okay, so this is the output. This is the output of cat proc / mounts. Please help me interpret this data. Devil Dog says, "Do you use linpeas?" I do use linps, but I like to enumerate the system manually before using linps because sometimes you can identify a privilege escalation vector a lot faster manually than using linps because linps gives you too much output and sometimes it's difficult to read. Okay. So let's see. Let's break down and interpret the output of proc mounts to understand the current file system setup. So we've got this right over here. The root file system / is mounted as read-only. This is a significant detail because a read-only root file system could heavily restrict what you can do, including preventing the execution of certain commands that require writing, such as sudo. The errors remount RO indicates that if any errors occur within the file system, it will be remounted as read-only to protect it from further damage. This is the device file system mounted as read-write, but with the no suid option. Oh, so let's see. So this one here. Jugpearl asks, quick question. I know it's off topic, but I was wondering if you think I should continue learning buffer overflow or I should continue learning buffer overflow's binary exploitation. No, I like answering any questions. It doesn't matter if it's about the topic we're talking about right now. And I'm here to offer advice about cybersecurity education, so your question is completely valid. So, should I continue learning buffer overflow or binary exploitation? So the question is whether or not, the question is what do you want to do with this kind of education? Do you want to become like an exploit developer, or do you want to become like a malware analyst? If this is something that's not related to work, but you really like learning about low level binary exploitation and like memory stuff, like buffer overflows, then by all means go ahead and keep on learning that stuff. I think it's very interesting. I'm not going to get a job doing binary exploitation and like buffer overflow, but I still think it's very interesting. Jug Pearl says it's just to sharpen my skills. Honestly, I feel knowing memory stuff is helpful for programming. Yeah, for sure. What have you learned so far? Because let's go off topic a little bit. It's fine. There's a fun website that I used to learn assembly, and I think it was called ASM Tutor. Let me see if I can find it. ASM Tutor. So this is going to teach you about using NASM assembly. So it's basically assembly for x86 for Linux stuff, for Linux. And let's grab you this. This is the link for the website over here. They do a lot of tutorials on how to write assembly. And this learning how to write assembly is actually very useful for reverse engineering. And additionally, like if you want to learn about to do some easy binary exploitation challenges, you can learn them over at PicoCTF. PicoCTF has a lot of binary exploitation challenges over here. And you know what? If you're interested, well, you'll need an account over at PicoCTF to see this page. But there are a number of binary exploitation videos that I have on my YouTube page as well. They're not super complex or anything, but let me pull them up. So these ones over here, let me grab this and I'll plug it into the chat. So these challenges over here, heap 0, heap 1, format string 0, heap 2. These are all binary exploitation challenges over from PicoCTF. They might be useful to you. At least I hope they are. Anyways, but let's bring it back. Perfect. Okay. Well, I'm glad to help. I think personally that binary exploitation and buffer overflow is very fun. It's very fun to mess around with program memory, but I understand that it's not everybody's cup of tea. If you think it's interesting, then definitely by all means go ahead and go nuts studying that stuff. In fact, I might be writing a course on binary exploitation and reverse engineering, probably sometime near the end of next year. It's a bit of a long way to plan for that stuff, but that's my plan. Okay, where were we? So we were talking about this one. So this is read as a no suid option. It prevents execution of files with the suid bit set, which includes commands like sudo. This doesn't affect sudo directly here because it's related to device files. The dev SDA1 file system is mounted on various subdirectories, /home, /root, /temp. With the read-write option, these specific directories aren't likely to affect sudo directly. So do I have to be... What does this mean? The run directory is mounted as read-only. This is weird. This is weird. The dev SDA is mounted in multiple places related to compat. Okay. Likely cause of the issue. Root file system is read-only. Since the root file system is mounted as read-only, it could be preventing operations like privilege escalation or modifying systems critical binaries, including running sudo effectively. If the root file system is in read-only mode due to an error, it may hinder many administrative commands. Mount options, okay. Next steps, remount the file systems as read-write. If you have sufficient privileges, you could remount the file system as read-write to restore full functionality. The command would be this. Okay, well I don't think I have permissions to do this. I could give it a try. I can't run sudo, but I could give this a try just for fun. Okay, I think it says you have to be a super user to do this, to run mount, so I can't do that. Check of sudo is on the no suid file system. If user bin sudo resides on the file system mounted with the no suid option, it will not be able to use a suid bit to evaluate privileges. In this case, you can verify the exact location of the sudo binary and check the mount options for that directory. So let's find the sudo directory. Which sudo? User bin sudo. The sudo binary is in user bin sudo. What are the mounts for that directory? From the output of the /proc mounts that he provided, user would be part of the root file system since no separate partition for user is listed. Therefore, the mount options for the user would be the same as those for the root file system, which is read-only. Okay. All right. So okay. So this is all to say that that we can't elevate our privileges with sudo. So I guess we can't elevate our privileges with sudo. So what does that mean? That means that So let's see, bin is user bin. So let's take a look at the opt directory to see if there's any optional software in here. There's nothing. Let's go over to the home directory and see what's in here. So we have a SA user and a Tor user. Tor is root backwards. We can't read any of the Let's try reading some random files. So we've got home, we've got SA, we've got .ssh, and we've got ID RSA. Let's see if this file exists. Nope, permission denied. Okay, let's do the same for Tor. Cat home Tor .ssh ID RSA. Nope, cannot access that one either. Let's move into the web directory. HTML. We only have index.html. All right. So nothing here. What else could we try? var lib tomcat. Var lib tomcat. So var lib exists, but not var lib tomcat. So cd var var lib lib var lib. Go into the other lib directory. Okay. Oh, we've got Tomcat over here, but it's called Tomcat 9. I wonder. We also have a lib library for sudo. Oh, it's a directory. That doesn't really lead anywhere. What are a couple more things we could try before we try something like what is it called? LinPs. So I want to explore everything else before. So how about we look at the etc password directory? So you've got SA. This is we probably want to do some lateral privilege escalation to become the Tor user or the SA user before we can compromise the system. We've got the root user up here. Let's take a look at the file permissions. LSLA etc password. Okay, this is only read. We only have read access on the password file. Let's see if there is weird permissions on the shadow file. So we don't have read access to the shadow file either. Okay. We're starting to run out of regular old options. Cron tab? No permissions. What else could we try? We took a look at the opt directory. We took a look at the... We don't have access to a proper home directory. We can try looking for scripts. So we can find in the entire file system, we can look for type file and name star.sh. And we can redirect all the other stuff to devnull, and we can run this as a background process. Okay, so these are all of the script files on the system. Let's see if there are any interesting ones. gettext.sh. Oh, one thing that we haven't tried yet is looking for the set user ID binaries. So let's look for that command. I think it's user binary privilege escalation. It's this file right here. I keep on getting the command from over here. So it's find with these bits right here. Okay. Okay, so we've got, these are the set user ID binaries over here. Let's feed this to ChatGPT and see if it can identify anything unusual here. Copy this. This is a list of binaries on a web server. Are there any strange entries here? Paste it in. Okay, typical and expected binaries found on a Linux system. Typical binaries, okay. Are you going to tell me about unusual ones? Potential vulnerabilities in CHFN, CHSH. Wait, what? Let me see. Okay. CHFN, CHSH. Were those included in here? CHFN. Okay, let me take a look one more time. CHFN, CHSH. Let's take a look at GTFO binaries. GTFO binaries. So this is a website where you can find we can find different exploitation techniques for different Linux binaries. So for example, CHFN, no. CHSH, no. CHSH, CHFN, user bin password. That's unusual. Or is it? Wait, let me take a look. Doesn't seem to be unusual. Weird. Okay. So maybe I should okay. So I think at this point, what I'm going to do is I'm going to. Can I run wget? I think I'm going to take whose advice? Devil Dog. Devil Dog gave the advice to run linpeas. I might run it. I might run it now because I'm starting to run out of options. So in order to run linpeas, we need to go over to. Well, I need to locate linpeas. Locate linpeas. So it's at privask linpeas.sh. I'm going to copy it over to the local directory. So copy like this. So now I've got linpeas in my local directory here. And I'm going to serve it on HTTP with the Python HTTP Python module HTTP server on port 80, like this. And then I'm going to download it from the victim machine. So on the victim machine, I'm going to go into my temp directory. And what is this? What is this directory? Okay, so this is, well, I mean, I have access to this directory. So let's hs per fdata underscore tomcat. What is this? Okay, this is a lot of information. But anyways, I'm just going to download. So 10.02.22, and we're going to download linpeas.sh. Okay, and did we download it? Yep, we did. This is an unusual directory to download it to, but it's fine. Okay, so we need to change mode on linpeas.sh, and we need to run linpeas. And let's see what happens. Okay. So linpeas is a whoa. I saw something. CapNet bind service. So this capabilities. So I actually haven't dealt very much with using capabilities as privilege escalation. CapNet bind service. It says that this is a very likely privilege escalation vector. So I need to pay attention to this. I'm gonna come back to this, but first of all, I need to go back into the rest of this output. This is the thing I mentioned about linpeas, is that you get a lot of information when you run linpeas, and it takes a long time to sit around and sift through it all. But okay, so we've come up to the top, and let's see if there is anything super noteworthy here. So we've got a bunch of exploit suggestions. Then we've got processes running as root. Okay. Apache 2 processes found. Socket files. network information, active ports. Okay, so we've got port 22. So none of these are user information, pseudo tokens, super users, users with console, last login of each user. Okay, software, useful software. Okay, so I think this might be our ticket because it's outlined in this orange over here. So capabilities. Like I said, I haven't dealt very much with capabilities, but first of all, let's get this. Let's copy out this output. We're going to ask ChatGPT how to exploit on capabilities in a little bit after we get to the end of this list. So I don't think. Let's see if there's anything else super interesting about this output. Okay, so I think that's it. So let's go over to ChatGPT and ask it a question about capabilities over here. This is output from the LinP's privilege escalation script. It seems to indicate that there is escalation through capabilities. Please interpret this output from the script. Okay. Okay, so it indicates that the current shell and its parent process have specific capabilities associated with them, particularly regarding network operations. Here's a breakdown of the information. So cap INH, inherited capabilities. This indicates that the capability to bind to network ports below 1024, which are privileged ports, is inherited by the current shell. Cap PRM, permitted capabilities, indicates that the capability to bind, sorry about that, to bind to privileged ports is permitted for the current shell. Cape EF, effective capabilities. This means that the effective capability of our current shell includes the ability to bind to privileged network ports. And cap BND, bounding capabilities. This lists the full capabilities that are bound to the current process in the case. Cap chown, cap set UID, cap net bind service, among others. Interpretations and implications. Okay, so what was the one that was, which capability was highlighted? Let me scroll up. Cap net bind service. Okay. How can we use the cap? How do you spell that? Cap net bind service. Capability to escalate privileges. Okay, so using the capnet bind service capability to escalate privileges involves creating a service that binds to a privileged port on a Linux system. This capability allows a non-root user to listen on these ports, which are typically reserved for system processes. Here's how you can leverage this capability for privilege escalation. So step 1, identify a target port. Choose a privileged port which you want to bind to, such as 22, 80, or any other port you suspect might be exploitable. For example, if you want to bind to port 80, ensure that it's not currently in use. Create a malicious service. Write a simple server script to listen on the chosen port. Here's an example in Python that listens on port 80 and spawns a shell when a connection is made. Run the exploit script. Ensure that the script has the necessary permissions and capabilities. You can set the capability using the setcap command. Setcap, okay. Now run the exploit script. Connect to the service. From the attacking machine or another terminal, connect to the service you've created. When you connect, you should get a shell prompt. This effectively allows you to execute commands as if you were in the shell on the target machine. Okay. So first we have to write a Python script. Write a simple server script that listens on a chosen port. Okay. So which port should we choose? Let's try port. Let's try port 53. 53 is DNS, usually. Let's netstat. SS? Okay. So right. Okay. So let's try this. Create a port and bind it to port 80. Listening on port 80. Connection from this address. Spawn bin bash. Let's rewrite that Python script so that it is a one-liner, because we don't have access to a terminal text editor on the target machine. Okay, so I'm going to copy this code, and then I'm going to go over to my Kali Linux machine, and I'm going to edit this. One-liner. Okay, so the one-liner is just like this. I'm going to edit it so that it's not on port 80. I'm going to do port 53 because port 80 is currently in use. And aside from that, I don't think there's anything else that needs to be modified here. All right, so let's copy this, then go over to the vulnerable machine, and then let's run this command using Python. Listening on port 53. Okay, so now that it's listening on port 53, we can just use netcat to connect to it. So netcat, let's see, 10.02.30 on port 53. Okay, who am I? I'm Tomcat. This doesn't help me at all. Okay, so oh, no. I forgot to modify the script. Oh, that's Kidboo says, what if you run a fake service to trick the user? Yeah. All right. So sorry. Sorry, I'm new at this. So what I need to do is I need to it's listening on port 53. I just need to I need to get out of here. Okay. So first of all, I'm going to reconnect to my reverse shell. And I'm going to go into the temp directory, and then I'm going to write a file. So I'm going to echo. I'm going to get echo. Whoops. I'm going to echo this stuff right here. And then I'm going to redirect it into a file called exploit.py. Wait, why didn't that work? Why did it disconnect me? All right, let's reconnect. Okay, so let's Python 3. Let's upgrade our shell first. Import pty. What if you run a Kidboo says, what if you run a fake service to trick the user? So what ChatGPT suggested after I gave it some information about the capabilities is that apparently this shell or this has some ability to give extra capabilities, which I'm not actually super familiar with, but it's something that I'm researching on the fly to find out how we can use it for exploitation. So import pty and then pty.spawn bin bash. Okay. And then we're in the temp directory now. So let's create a file. So actually, let's just let's recraft this. So let's go back to our Kali shell and start editing this. So we don't want, we want this to be an echo command. We want to echo all of this stuff out. And we want to redirect it into exploit.py. Oh, okay. Redirect into exploit.py. And that creates a file called exploit.py. Okay, this is what we want. So let's copy this command, and then in our shell, okay, so now we have exploit.py, and we can start modifying the capabilities on it. So ChatGPT, how do we do it? So how to use it. Make sure that the script is executable with the necessary capabilities to bind it to port 80. Okay, so sudo setcap. I can't run sudo. I can do setcap, I think. Then execute the one-liner directly on the target machine. Wait, was this different from sudo setcap exploit.py? No, we want to do this. Have you tried, Extremely Big says, have you tried sudo l what you have sudo to? We've tried sudo l, but there was something really weird that happened when I did sudo-l in this case. It said something about the file system being all weird. I might, yeah, so, okay. Let's go back and let's run this state capabilities command. It says unable to set effective capability operation not permitted. Okay, so what if we do sudo in front of that? Yeah, so sudo doesn't work in this case. Huh. All right, so it looks like I'm gonna have to put a pin in this because it's getting kind of late and I need to have dinner. I'm getting really hungry. But thank you very much to everybody for watching me struggle over here. We'll probably continue with this machine in the next stream. The next stream is going to be on Friday. And meanwhile, let's see if we can find some fun InfoSec streamers to raid into. We've got Hack Smarter. Okay, Hack Smarter is a great hacker, and he's got a he's a very he's been in the industry for a long time, and he's usually doing some fun stuff. Let's find out what he's doing right now. So let's go over to Hack Smarter, Twitch. Hold on. Let me get his stream address. Copy link address. Let's mute this. Okay, Hack Smarter is doing study with me, ethical hacking. Oh, he's doing Pomodoro. So you can go into his chat and you can start asking any questions you want about cybersecurity. And this is not Hack Smarter, obviously, but yeah. Please join us for the raid, and please type as your raid message when you get into his chat. Type hip hop and attack, if you please. So let's set up that raid. But before we go, let's do one last hack the planet.
Hack the planet! Hack the planet! Shut up and get in the...
All right, the raid has been created. So everybody, please go into Hack Smarter's channel and type the message hip hop and attack. Hop and attack with the OS frog. Just like this. Okay, everybody, see you there.